So let's get rolling. And we got, again, a lot to cover. Myself, G. Truglia, Rich Peterson will be your instructors for tonight. We will be hooking up to wires you see under some of your seats. If you brought your meter and your lab scope, we're going to help you make sure you're on the right scale and know what you're reading. We're going to generate some stuff from Bernie's board up here, the E-trainer, and then you're going to get these signals. But first, we're going to give you some good basic stuff. Hey, Mr. Les, how are you? Okay, good to see you out. Now, here's some of the tools that I have. I own every single one of these tools, and it's not every one of them, but that's a hell of a lot of them. And you notice up here, I have a meter, and I have a Snap-on Vantage graphing meter. If you can use a meter, any of the meters, doesn't matter, you can use every one of those scopes. That's what we want you to get the feeling of. You notice tonight it says also part 1, okay? Because one of the things we noticed, how many of you guys have taken a hands-on test on the board? Some of you, okay? A small amount of us. You really need to prove to yourself that you can get through it. We had over a 50% failure rate. You know, it's good to study for a test, and like I said before, ASE is something we need. But guess what? The car doesn't know you passed the test. The car only knows if you're going to diagnose and fix it. You got to be able to do it with your hands. We had a big playoff in Las Vegas a few years ago. We probably gave away, I think it was over $35,000 worth of prizes that some of our sponsors donated. And we could not even get to the hardest test on these boards. Okay? We'd like you to take electrical 1 and electrical 2 to see where you're at, so you know where you need to brush up. That's why we're going over this. Like a house. You don't put a new roof on a house if the foundation sucks, right? Need a good foundation. And we're going to go over that. Some of the stuff you already know, some you don't. I guarantee tonight, we give you this much information, maybe you walk out with this much. Some of you guys may know a lot of it, some of you may not. There's nothing wrong with that. You don't know, no one is stupid. Okay? So now the thing you hate most, Ohm's law, I'm sorry. Okay? Ohm's law, voltage, amps, and resistance. Okay, I'm not going to spend a lot of time on this. I want you to look at it and realize that this is important. I'm going to show you a case study where this comes into play. So I'm not going to bore you, because if you want to read about Ohm's law, you need to get a book on it, or a book like mine, and read a couple of pages on it. This is real world Ohm's law. This is super important. So forget about what you just seen in the previous slide for a second, and know that ohms, when they're low and we have a constant voltage, amps is up. When ohms are high, amperage is down. Okay? Again, with a constant voltage. This is super important because computer circuits are going to burn out if we have too low of resistance and too high of amperage. Does that make sense? You know the most expensive fuse on a car? It's the computer. Okay? And what do people do? Computer burns out? Oh, I just call the parts dude. You plug in one, he blows, the next guy sucks, and guess what? You're an idiot. Because it had to blow for a reason, right? You just don't play the plug-and-play game. What caused the computer to go? We're going to show you something in a little bit where you need to go through every solenoid, not sensors. Sensors don't cause something to blow. Why? Low amperage, right? TPS sensor going to blow a computer? I don't think so. Okay. Oxygen sensor, not the heater. Okay. Oxygen sensor going to blow it? I don't think so. Okay. But is a fuel injector going to blow it? Yes. An EPC solenoid. Okay. It's a tranny solenoid. Okay. Shift solenoids. EVAP solenoids. You bet your butt. They're all going to cause a problem. Does that make sense to everyone?
A lot of bad Toyota computers out there right now.
And sometimes, like Mitsubishi, or I like to call them Mitsubishi, one day they just wake up and die. Okay? They just go, we're dying for no reason. Just their day to die.
The Toyota is a huge problem right now.
Chrysler, overall, we go by overall, not many of them die. I mean, have I seen them die? Yeah. Or some of the Hondas that, people spill stuff under their seats, they used to go. But overall, there are certain computers that have issues, like all the GMs that used to blow like this. Okay? Yeah. But when you see a blown computer, you need to check every actuator on that car. And never stop till you get to the last one. If there's 50 actuators and you go, oh, I found number 20 is bad, that's it. You stop. What happens, Rich, when they stop?
They stop.
They stop, you may get screwed, there may be another one. Maybe number 48 was not your lucky day, was bad. Low resistance, high amperage, right? So keep that in mind, gentlemen. Now, go ahead, Mr. Rich.
All right. Let's start out with a little scenario here. All right. I get called many times from computers that smoke. All right. And I have down here, I cringe whenever I get a call from a shop where they've smoked computers. That's plural. Not just one, but they've plugged several computers in. That's what Jerry was just talking about before. All right? Now let's look at this computer. All right? Jerry's pulled this in here. This is a diode pack. These are resistor packs. They're across the outputs of the certain outputs in the computer. There's multiple diodes in there. They're for suppression. All right? Now, this happens to be on a Toyota. All right? Toyota, there's a lot of problems out there with Toyota computers right now, and they're burning up like this here. And let's find one of the problems. All right?
So look at this. This pack is pretty melted.
Yeah.
If you simply put another computer in, sometimes you're lucky where maybe the car gets out the door or whatever. Sometimes it doesn't even make it out the door. There's got to be a reason why it burned. Does that make sense to everyone?
Well, this is what's happening. As Jerry said before, if you're talking about sensor circuits, they can short out, drop the 5 volts out, but usually the 5-volt circuit is protected.
Usually.
All right? Usually. It's protected, all right? And if it drops out, once you clear the problem, it can come back again. I'm not talking about the problem, but the circuit and the system can come back. But this here is an output circuit. That computer's not coming back.
It's dead.
Right.
It's buried.
And that's gone. All right.
The grass is
They
gone.
won't even repair it. It's a 2002 Nissan Maxima. All right. Now, this is what I got to call. As a matter of fact, who sent me this job? John Anello sent me this job.
Where's Auto Tech on wheels when we need them?
Is that why you're here?
All right.
going to say that.
In any case,
And as you know,
he went
John is
there.
a sharp guy.
He went there and
Sometimes he needs Rich.
he just doesn't want to,
He's busy.
He's busy. He says, I can't spend the time going through it. He said, and it took me a while, and I'll actually tell you why. All right. I checked on this car all of the outputs, all the solenoids and everything on the car, and everything checked within specs until I got to something I had never seen before. All right. I heard of it out there. John told me the same thing. He heard of it, but he never saw it.
But
when I called
Rich, what was the complaint on this car is the biggie. We're telling him you got called, you got John.
Right.
We don't need to know you're in love with John. That's a little ballgame, okay? We need to know what was the complaint with this car.
The complaint of the car was the fact that John was called on his car to put a computer in the car because the computer burned up. John was called to program the computer. All right, the new computer. John hooked up to program the new computer. They turned the key on, start the car, and John all of a sudden goes, "Do you smell something?" This is a story I got right from John. Okay? All right, so now we're talking about, after this, all right, there'll be a third computer. Now, John also has pictures of this because he took pictures of this also, and he's probably going to be writing something up on this. But in any case, all right, so this is what happened. So I decided, well, let me go in and check all the circuits in the computer. All right, I did. I found one thing that I had never found before in the computer, and that is electronically controlled motor mounts. All right? I've heard of them, but I've never been involved with them before. All right?
You've seen them on Hondas and other cars, right?
I looked in
Familiar.
my information system. I looked in other information systems out there. I found a description of the system. But when it came to tests, the only thing I found was visually inspect both motor mounts, and if you see a problem, replace them.
No specs.
No specs. I found no specs on it at all.
We're going to show you that.
Mm-hmm.
You should
All
talk
right.
about this, Rich, right here.
Right? Okay, so I looked in the wiring diagram, all right, and I see how they're hooked up. All right, you have B plus coming in. You've got zoom in on that. Right, we got B plus coming to both motor mounts. All right, and then you have two coils in each motor mount. So it's 4 coils altogether. You've got a soft and a hard mode coil. All right? It goes into soft mode at an idle, and when you're driving it goes into hard mode. Look at what it takes to go into it.
You're blind as me,
Yeah.
Rich. is what you're telling me.
Look what it's reading. It's reading RPM, crank sensor, okay? Wheel speed, vehicle speed, all right? And it adjusts the motor mounts, all right?
And look how important these sensors are. We all know that the crankshaft and the camshaft are going to be for drivability issues as well. So we have different information that these sensors are putting out to multiple type computers. Make sense? Just like you use stuff for transmission, right? Sometimes you use the same sensor. So
To
keep
the
that in mind, that the sensors must work good first. And this is courtesy of all data. You can see I took the old data page out to show you there wasn't a lot in there. This is what's in there. I pieced the wiring diagram
Same.
with their spec page in there. You don't see something about resistance, and you may want to tell them, we'll go back to that other
Right.
page.
You can go back.
What you
yeah.
found.
All right, and what I found, all right, is that 2 of the coils, now the coils are in parallel, all right? The front and rear soft coil is in parallel, and the front and rear hard coil, mode coil, is in parallel, all right? One of the coils was at 75 ohms. One of the sets was at 75 ohms. The other one was down at 7 ohms. They both should be the same. At 7 ohms, it's going to burn out that computer.
Now, why again? What did we learn just a couple of seconds ago with Ohm's law? Low what? Equals?
High current.
You guys got it.
And
It's
this
that
system,
simple.
this system is not a pulse width modulated system. It turns it on, one on, or it turns the other one on. So it's on at all times.
Why did you blow the fuse?
Didn't blow the fuse. I can't tell you that because the fuse is probably a 10 amp fuse.
Too many amps.
If you figure out what the computer can use,
Five.
all right,
Protect the computer.
7 ohms, 12 volts, it's about 1.2, 1.3 amps.
Probably about 1.3.
1.3 amps. Okay? And it's not enough to blow the fuse, but it's
But enough to
certainly
burn
enough
the
to burn the computer.
And you're going to see the example, anything more than 1.2 amps for more than 6 milliseconds is where you're going to run into a problem. Okay? How many milliseconds does it take to make 1 second? 1,000.
1,000,
How many
right.
millivolts to make 1 volt? 1,000. The milliamps, 1,000. Okay? So think about 6 milliseconds. My cheap Timex watch over here, that's a second. That's a second. Every time I do it, it's a second. Took 1,000 of those milliseconds in that second. That's pretty damn quick, isn't it? It's like going across the battery like this real quick. If there's no hydrogen gas to blow my ass up, if I do this real quick, it's only going to heat the wire up I'm doing, right? So if we do something quick, like a pulse modulated injector, you guys familiar with those?
Yeah.
Performance cars? They could pull up to 7 amps, but they go, then it goes, because it pulls it quick to open it up so we can get the fuel in, pulls the 7 amps momentarily, and then what's it do? Levels off at 900 milliamps. A starter motor on an 8-cylinder. A good starter motor on an 8-cylinder could pull 650 amps. And you go, get out of here. Yes, it will, for a few milliseconds. Why? You got to get that motor starting over. Then, of course, it goes down to about 125, 150 amps, which is normal, right? But we don't realize these things. You look at your VAT or AVR type of starter system, you look at it and you go, I never seen that. Put it on a lab scope. I got a picture in my book of that. I do this in classes. We take these big amp clamps, we go around the cable, and guess what? I'll show you that. You just don't see it. Why? because your equipment is not fast enough to see it. You need to put this on the Modus, the Solus, or any type of lab scope type thing, a Fluke or Tektronix or whatever you have to actually see that. Does that make sense to everyone?
Yeah. But amps kill you for voltage.
Yeah, amps is really burns things up. You need proper voltage. If you don't have enough current flow, you got a voltage drop. Okay, and that's what you got to keep in mind. A lot of people don't realize that. You know, a little quick story, when I was doing some stuff with Delphi Aspire before they bought Aspire out, they were going to come out with every reading of amperage for even senses, because the sense is going to use some amperage, which is going to be very, very low, obviously. Okay? And they were going to do diagnostics by just taking their tablet that they had made, I forgot the name of the system, and take an amp clamp and click on stuff and see if you were in an expected range. Too much amperage, too low resistance, you're going to have a problem, right? Too little amperage, you got a voltage drop. And you need to check that circuit either way. And if you're right in the money, what does it take to do an amp clamp? Click on the wire, click, click. Rich could have used an amp meter here, but he used something super simple, right? That Oli has probably got a feeling for, and that's using an ohm meter. Okay? Even if he didn't zero his leads out, there's a big difference between 75 ohms and 7 ohms. You're not going to get that much difference of resistance with the leads, correct? So this is why simple stuff, you got to use the simple stuff. You know, I get a lot of vehicles that come to me over the years, problem cars from different places, dealerships, tranny shops, the whole bit. They miss the simple stuff. Not because the guy's stupid, he's lazy. And he forgot the basic stuff. He wants to pull out the scan tool. Scan tool is a great tool to start with, but you need a meter or a scope to follow up with. Make sense? Let's move along. Show Mr. Rich.
Here's what happened too. The guy did, John had said, this is what John told me. He says, the dealer told him they disconnect the system. He was under a vehicle, a similar vehicle to this, and he said, what are these wires hanging down? And he said, the dealer said that they're just from the motor mounts. We disconnect them because we have computer problems with them. All right? And this is what I was told. All right? And this is also what the shop wanted to do, because the guy didn't want to go for motor mounts, electronic motor mounts.
How much are they?
I can't even tell you. I didn't check. I have no idea.
Well, the bottom line is this a good fix? Now, on the newer Nissans, you'll get a light that comes on.
Yeah, you may get a light.
The older ones don't throw the coat. So you got away with cutting this stuff, but is this the right repair? Let's say I'm working under the car, you're working on the car, you see a broken wire, what are you going to do?
Put it together.
You're going to put it together. Smoke show.
That's it.
I mean, this guy leave you a note. Hey, Bob, guess what, dude? I cut the wire for bad motor mounts. The guy was a cheap SOB. He didn't want to fix the car. He's not doing that, right? And we're going to make a mistake and put it together.
Absolutely.
I mean, it's just logical, right? So the real fix is tell the customer, look, this needs to be addressed, because remember the high speed and low speed? That motor mount, if it's in a position where at low speeds you get a lot of vibration like this, motor mounts are the issue, correct? You ever put a cheap pair of non-OEM motor mounts in? And the car never had a vibration before, but now it vibrates. Nothing to do with electricity. The rubber composition is different. And if you put too soft of a motor mount, what happens to all the torque in that drivetrain? It's going to be an issue. Could we do damage to the drive line? Sure. So this thing needs to work, and you need to explain that to a customer. Okay? And you can see that electricity is super important in suspension systems, in drivability things, in transmissions, everything on the car, brakes, air conditioning. You need to know this basic stuff.
Oh, yeah.
Okay?
Absolutely.
So cutting that's not right. Now, remember I told you before that low resistance equals high amperage? Do any of you guys recognize this tool? How about you, Mr. Chris Lewis? Do you recognize this? Okay, this happens to be an essential General Motors tool. It was made by OTC SPX. You notice all these computer boards? I took the latest one out for a 1996 GM car. I have this in the training center. Back here is a chart of every solenoid on every car. There's a dial here that has about 24 plus numbers of every actuator that was on that GM car. It tells you right in the literature what the solenoids should be pulling. it displays in milliamps right up there what it should pull. The reason why they came out with this, do you remember early General Motors, these early computers, the little pins, right, the dual layered boards? What happened to the computers? They smoked. It was like a cha-ching when you seen one of these things. You know you're going to put a computer in a car. It was a moneymaker, correct? In fact, they were stealing so many cars in the Bronx, stealing computers out of them, the carbureted controlled cars. They still ran, right? But these computers were burning big time. They were selling these computers. That's how hot they were. So General Motors addressed the issue by having this tool made for them. It would tell you in milliamps. And they figured, hold it, these guys still won't get if it's bad. So what did they do? You see this little thing right there? The little thing right there is not a yawn. No, that's not right. That little thing tells you that it's overcurrent, is a short. In whatever solenoid that this thing, go into the chart of the computer, will give you the computer number, it would tell you that, let's say it's the evap solenoid, or let's say it's the fuel injector. It would tell you that that particular circuit on that car was shorted. You needed to change it before you plugged in the most expensive fuse in the car. That make sense? Now, that's interesting, and they tell you anything more than 1.2 amps is going to blow the computer, because computer circuits are very small, as you've seen. There's no big wire in there, is there? Okay? So we can't pull a lot of current. So what do you do if you don't own this tool? Here's what you do. You take a digital voltometer that you should all have. And by the way, I may tell you your digital voltometer sucks or blows later, depending on if it doesn't have a few features, like min-max, pole, frequency, duty cycle, and milliseconds for automotive use. Okay? And if you're ever going to get into hybrid stuff, you need a Cat-free certified 1,000 volt meter if you're ever going to do that. If not, your meter at least needs that other stuff. Now, we can look at a wiring diagram, this one courtesy of Mitchell, and find any solenoid. Most solenoids are ground controlled by the computer, correct? Meaning they get power from some other source, like the ignition key gets turned on, a relay sends power out to whatever solenoid's out there, fuel injector, whatever, correct? Now in Mike's world a lot, in transmission world, it's the opposite thing. The computer toggles power because the solenoids are grounded already. Does that make sense? That is a different setup. Not on all of them, but on some of them. A lot of European cars do that. That's correct. In fact, the old Renix systems, if you worked on any old Mercedes or Peugeots or some of the old Chryslers with the Renix system in there, they did that very same thing even on fuel injectors. Okay? So you take your meter, you get to a good ground on the vehicle. Okay? You're grounded. This is simple. We go to every solenoid, and what you're doing is you're activating this once you touch that pin, and you could read the amperage. Knowing the amperage we have here on DC amps, a line in 3 dashes, DC amps, how much amperage am I reading on that meter? 1 amp, 500 milliamps. Is that more than what I told you is the max? Yeah, it's too much. Guess what? That's going to cause something to burn out. It can't flow that much current. You also have to notice, like if we did an EPC solenoid, they're going to pull a lot, right? You got to notice its duty cycle. So what does that mean to you? Well, if you first put it on, of course it's going to pull more amperage. It's used to doing on-off. So you got to know sometimes a little bit about the circuit. But can we do the same thing with this tool that we just did with this tool? Yeah, it's going to take you a few extra minutes. But guess what? You do everything. I never ever change a computer without going through everything here. Now, what happens if the computer had powers going in, like it does? We have grounds like a 60-pin Ford computer, 10, 20, 30, 40, 50, 60, all grounds, right? 104 computer, all the 10 numbers are all grounds, correct? And then we get 12 volts going in. How many solenoids get power and ground going to the solenoid? One of the things we don't have is a little flip chart here to draw on, do we? Well, you all realize that a solenoid, like this fuel injector or evap solenoid here, has 2 wires going to it, correct?
Yep.
You always have to identify what side has 12 volts on it, what side has ground after you disconnected it. You may want to take a back probe pin go in and find out what side is the power side. Why? Who could tell me why do we want to know that? No, not because don't blow a fuse.
Computer's sitting.
No.
When it's not grounded, you'll get voltage on both sides?
Well, that's true. That's a very important point. If it was plugged in, you would get voltage on both sides of the terminal. I said unplugged, but that's good. I'm glad you brought that up, sir.
Plug the ground.
You want to see what side this is, so if you use any power control like a power probe, and we stick it in the wrong side of the solenoid, you just burnt that solenoid out because it has a diode in it. A lot of them are using diodes, whether they be European or domestic cars. That's why you need to check that first. Oh, no wonder why you didn't have an EVAP problem until you unplugged it and checked it. Because you put power to the wrong side of it. You got to make sure the solenoid works, but you got to make sure what side is the feed side. Does everyone understand that? Any questions on that? Because they put diodes in there. Sorry?
The wiring diagrams before you touch anything.
Yeah, but you know what? I don't even trust wiring diagrams all the time. I've been screwed on some wiring diagrams. They tell you, the color is whatever. Work on some
All
Nissans.
data don't tell you anything.
Well, all data gets the factory wiring diagram. Personally, I like all data, but I consult Mitchell as well, but I'm always going to do this. 9 out of 10 times, I'm not going to use the wiring diagram for something like this. I'm going to use my common sense. And the common sense ain't going to screw me. My meter is not going to tell me the wrong side, right? I'm going to really know what side is right. In fact, there were some cars on the West Coast, I won't mention the car maker, but they were having a problem with EVAP solenoids burning. The wiring harness, the wires were switched. Okay, they were on the wrong side. And they were popping quite a few of them. They had EVAP codes because it was a state issue that it was working in a particular state that we found that out. So they popped all these things. They had to get a whole bunch of new EVAP solenoids and purge solenoids. So you got to be careful. You got to realize what we're dealing with. Here, what you do is you unplug the wiring harness because let's say this pin here is power coming in and that little terminal needs power and ground. You take the power probe, you put power to that terminal, you put ground to the other part of the solenoid, okay? You could put your meter in series of this, can't we? And what I mean by that, Rich, could you be my Vanna White for a second, please? You don't look like Vanna White, but, all right. Show them what we're going to do by putting that in series to a pin. You hold one, I'll hold one.
Oh, yeah, there we go.
Okay? So if we were going, we're in series, correct? We're going to see what current, and by the way, our jacks would be, not to confuse anyone, in the 10 amp jack would be on DC amps, and we would be like this, and meanwhile we're powering it up. So the two wires that are going to the solenoid, I don't care if it's a fuel injector, EVAP, whatever, are going to have power and ground. We now can see if we have more than how much amperage it's bad? 1.2. Does that make sense to everyone? Now, if you're in the real world and don't want to blow your meter, and by the way, when you're done, always do this. If you don't unplug it, I guarantee you put it in the toolbox, you go test voltage, there goes your $8 fuse. We're going to show you a couple of good ones with that too later. Here's what I do. You need to break down and buy an amp clamp. Okay? It makes life a lot easier. It's easier to do this, okay? It's easier to click on and go. Don't need to put it on a scope. I could, but do I need to put a scope on this? Do I need to take out the B-52 bomber to do something a little artillery can take care of? Hell no. Right? We can see the amperage 1, 2, 3 with an amp clamp. Even if you buy the ones, I don't know if you brought the other one that has the little reading on it.
Yeah, I have it at some.
Okay. But you guys know what I'm talking about. Some have the little numbers here. Quick check. What's it take to do this? You're done. And sometimes you may not need to use the power probe. If the computer is still alive, we can use bi-directional control in our computer. I mean, in our scan tool from the tool to the computer, correct? We could actuate things and then see what the amperage is. But most cases you're doing this because the computer died. Is it going to take you a half hour to an hour? Yeah. But guess what? That's what you should be charging for. John gets what, $200 an hour to diagnose something? Charge your customer $200 an hour. I shut my shop over 9 years ago. I got $193 an hour to diagnose it, $93 an hour afterwards. Guess what? People will pay if you do the job right. I used to sell my customers on, if I can't fix it, you owe me nothing. And they look at you, go, oh, okay, how could I go wrong? And in an hour, you better know which way to go. It's like driving on a road. You're not going to drive through this cockamamie, New Jersey here and not know which way you're going. Oh, that's right, you can. North to south, south is north. It's all screwy over here. Okay? But guess what? You usually know which way you're going, correct? So keep that in mind, that you need a plan, and this will help. Any questions on this? Good, we'll move on. Now, just like we told you, battery charging. Something simple. I got a question for you. Car comes in, no start. First thing you do? Battery starts going dead. Next step, gentlemen, you put the battery charger on it, don't you? And you didn't observe what the manufacturer has been saying for years, which is what? Disconnect the battery cable from the battery while charging the vehicle in a car. You'll see that later right from a manufacturer, and that's in every manufacturer's material. You disconnect it, but you don't do that because you think this is your father's Oldsmobile years ago. Maybe your father didn't even have one. He had a Plymouth. Okay. But guess what? He had a Ford. Okay. Just as good. Guess what? You don't do that, you're going to get what type of problem diagnosed in the car? You're going to get AC ripple, aren't you? That could skew some of your readings up. So you got to be careful with that. But you don't think about that. You don't think about, do you know what the right battery voltage should be of where you check a computer system?
12.65.
Okay, 12.6 is a fully charged battery.
12.5.
What's the lowest amount?
12.1.
Close.
12.1.
12.45 is 75% charge. 12 volts, 450 millivolts.
Well, can we get the box, plug in, take the battery out, and,
No, I would just go with a regular battery in the car. We'll talk about this later, that certain battery resistance. We'll tell you a couple of battery stories later that will screw you over. So you want to have the batteries in the car. Now, if you have a whole bunch of interstates or deckers or whatever that you know are for the vehicle and are good, you know, you don't have time to go charge this thing up. Take it off the shelf if it's good. Put it in there, start your testing. Make sense?
black box, when you plug it in, you take the battery out, and that's your,
I wouldn't play with that because the manufacturer doesn't recommend that.
What about,
Not on these circuits nowadays.
what about the new chargers for that have for the programming? Is that acceptable?
Nope, I still wouldn't put that on because no manufacturer recommends charging that battery in the car when you're doing that. And it'll skew you on diagnostic testing, okay? So battery charges, you can see there's all different types of battery charges here. And when you guys charge batteries, side terminals, you see these things? You may have them, but you never use them. You put a bolt in there. Guys, that's not the way to charge the battery up. And the battery is the whole electrical powerhouse of the vehicle, isn't it? Simple stuff. But a mistake you make simply is going to turn into a big problem just in a little bit. Again, just like the battery charger on there. I know. How many guys charge the battery in the car? Done it a gazillion times. Sometimes there's no problems. Sometimes there's a big problem. You can even spike stuff going on and off with it. Anyone own anti-zap? It's a little piece you put on the battery to prevent any spikes in case you got to do that. It's a little, you know, like a surge protector for your computer. It's a little thing. You can buy it from AES, Napa, CarQuest, whatever. Has a little light. Some guys are insane. They weld with this on the car. Students will weld with it. You'll see the little thing go on and it catches the spike. It lights up. I'm like, you'll see it works good. I go, dude, how about when the light doesn't light up? You don't know at that point, do you? Now, some of these little battery chargers, you're going to see how they come into play. This associated 20 amp battery charger is good on glass mat batteries, as well as this expensive Medtronics that I have is good on glass mat batteries. You got Mercedes with glass mat batteries. Okay, you got Toyota Priuses with glass mat batteries and some other high-end vehicles that are using them. Now, here's another big problem in this industry. You've all tested with stuff like this because Rich took that picture, I took that picture. Guess what? And I got a gazillion of them. Pierre was called out not long ago for a problem car that had some codes on a BMW, and it happened to be a problem with the battery terminal. Battery terminals, how many times I've done one of these and they're loose? You know that old saying, wiggle, jerk, feel, and massage? You got to do it. Just don't get too excited. Your pants get wet, I walk out of your shop. I send Rich in for that one. Okay? Emergency ends. You know you all got these in your shop. You're all lying right now, I can tell. You've all put these on, haven't you? You cheap bastards, you. You see this kit here? That kit cost about $450 with everything you see there. The big pliers to crimp them, all the ends. You can make diesel cables. You got 4 gauge, 2 gauge. You got all those crazy ends, eyelets, the whole bit. You need to invest in something like this.
You got those Nissan ends with the bolt?
The dude has all the ends that sells it. But you can buy this through Worth, Rogo, probably CarQuest, Napa, or some dude I know sells these kits. And by the way, when you make those ends, you can make yourself some good money. He even has a chart. I forgot to bring some paperwork for you. He has a chart on what you should charge, your going rate. You ever put a whole new cable in, how much that cable is? You could save yourself a lot of money, dude.
Who makes the kit?
I know Rogo. Years back, I had a Rogo kit. My pliers broke. This new setup I have, these jaws are amazing. It's real easy to do it. This guy, a buddy of mine, Dennis Rodenbach, up in Utah. He sells them. He does a lot of stuff out there with diesel trucks and cars. He has a big shop, and he sells equipment like this. So it's a good investment. Once you have that, these things are peanuts. You're talking, all that other stuff there. This is like probably $180, $190. That's probably $40 or so. That's the stripper and the crimper. You can make a lot of money, do the job right, so it looks like this when you're done. Not this cockamamie problem where you got a huge voltage drop, and we have a case study coming up, right, Rich? Where you don't realize what happens here on a voltage drop. What's the result of a voltage drop right there, that close to the battery post?
Well, he could turn on and burn the battery.
It could burn the battery. What else could happen? It generates what? Heat. Okay? And we get a poor connection, don't we? Does current flow drop? We start burning those little strands up. Those strands start burning up like the hair on my head, right? They start just going. All the strands start going like this. Gone. Okay?
I got to mention though, this does not work, guys, on battery separation terminals. You can't replace a BST that's fluid incident. It goes pyrotechnic after a crash by the airbag module.
That's what he's talking about.
One of these.
Right, he's talking about the airbag module ones. This is on conventional terminals. The other ones you do need to buy, those little explosive ends for the airbags and stuff, BMWs and so on. Those you need to buy from the dealer. But how many of these are out there? This is missed opportunity. How many of you guys check the top of this battery to see what the voltage is on the plastic case? Hey, that's a $15, $20 job. Years ago, that's what I used to charge. Battery maintenance. You buy that stuff, NOCO, I think it was, that purple spray crap at the little things. Clean this up. Don't use baking soda to let it go down in the hole. If the guy didn't need a battery before, he'll need it now. So you don't want to do that. Clean it up. Clean the terminals, because if that guy gets stuck on a cold, rainy night or a snowy night, you're toast, dude. He don't want to come back to your shop. Okay? So this is, again, basic stuff. How many amps is required to charge a glass mat battery? And you're going to see why this is important. Anyone know? 3.5 amps. How long would you expect to charge this battery? That happens to be a Prius battery. Is this going to be 15 minutes? This is going to be hours, depending on how bad that battery was. Again, this little charger here can do it, believe it or not. It's only a couple of $100. You probably spent more money for some big-ass unit you have that won't do what this one does. This is a very good charger. It's a smart charger. It's about $1,500, but it kicks ass. And anytime you buy a charger, I know Snap-on makes one, I didn't have a picture of it, but you got to read the rating. Not all of them will go down that low to do 3.5 amps. That can ruin the battery. Toyota Motor Company, what do you see there? Oh, it's Toyota on their bulletin with an associated battery charger. Hell, that looks like the exact same charger there. It is. Just with Toyota's name on it. And I want you to see what it says. Do not charge with the battery mounted in the vehicle. That's number one. They never want you to charge. And this, you can look at BMW, Mercedes, Chrysler. No one wants you to do this, but you do this anyway, don't you? You're not supposed to charge the battery in the car. Also, caution. Use of standard battery chargers not recommended on the Prius 12-volt auxiliary battery. To prevent battery damage. So these cars are going to be coming in your shop. You got to be prepared what to use. And no, by the way, you know when you get a dead battery, you never put it on how many amps should go in there correctly. That's what's nice about that Medtronic battery charger. What do? You go, high boost, where is that thing? Right? What's the maximum temperature that battery should get to, the case temperature? 125 degrees. Okay? On any battery. That case should not get over 125 degrees. You got a lot of companies now putting battery temperature sensors there, right? Remember, Chrysler always used a calculation on the temperature. Why are they doing that? They don't want to overcook this battery. Does that make sense? Well, that means don't use high boost because your battery charger is not a smart battery charger. And of course, God forbid you put it on timer, you put it on hold, you got to eat lunch, you got to go to the toilet, you got to go for a parts run, right? You just go, you're ready to roll. I know the deal. Been there, done that.
How about a jump start on those glass batteries?
Not directly on the battery, but under the hood. On a Prius, they give you special spots where you got to jump it. That's to prevent that arc, and you got a lot of resistance from the front of the car to where the battery is in the back. There's a little terminal in a box, and you use a battery chassis ground, excuse me. Make sense? Okay, so should you charge your battery while it's in the vehicle? You already know it's no. What does CA stand for? And Rich and I were just talking about this the other day. Cranking amps. Well, it's cranking amps at 32 degrees Fahrenheit. And it can deliver it can continuously deliver for 30 seconds and maintain a terminal voltage equal or greater to 7.2 volts. This is also MCA. You know when you see MCA on some of the testers? This is like a marine battery. You're going to see why this is important in a second. Because so many of you, or the customer, chooses the wrong battery for the car. And you don't realize that. You think, I'm going to go with this next one that says CCA. You all know this. This is the most common. Cold cranking amps. That's at 0. Okay? But how about RC? Not RC Cola, but RC. Reserve capacity. This is pretty important, isn't it? Reserve capacity is conducted at 80 degrees Fahrenheit. And of course, you will have thermometers in your shop. You know when it's 80 or not how you're testing this, right? Okay. And should be able to discharge at least 25 amps, some more depending on the rating, and hold the voltage at 10.5 volts. So when you're driving home on that Garden State or wherever you're on and your fan belt goes flying off or your alternator takes a crap, that vehicle can run for a certain amount of time. Does that make sense? Now Rich, add to this with this reserve capacity and CA rating and so on.
All right, let's go into, everyone knows your cold crank amp rating on the battery. Now let's say a customer comes in and they have a problem with their car. Either the charging system's not working properly, or you've got a lot of accessories on the car and it drains the battery a little bit over. Nothing, it doesn't drain it down so that it doesn't start, but it always drains it down low. All right, a little bit. All right. What's happening with the reserve capacity on the battery? All right, as I said, this is where the reserve capacity comes into effect, is this ability to be able to take any of these, while the vehicle is off, these light drains, or working the interior lights for a while, or whatever.
Or computers going to sleep for a while.
Computers, right, going to sleep. All right, it's going to handle this with reserve capacity. All right, now, once the reserve capacity gets a little low on a car, a lot of people will turn around and say, or shops even, will turn around and they'll say, well, we're going to get you a new battery, and we're going to get you the biggest battery that we can get you for the car. And I don't mean physical size, all right? They look in the book and they say, well, let's get the highest cold, gee, I got one with 1,000 cold crank amps. All right, that's got to hold up real good in this car. All right? Now, what did we say before about cold crank amps on a car? Jerry explained that real well, and he said the amperage may only go up to 600 amps for a split second. All right? Why do you need 1,000 cold crank amps in the car? You don't. And you have to remember something. For the same size battery, if cold crank amps go up, what happens to reserve capacity? It goes down.
Boy, how many of you guys own boats? No boat owners? Only one guy? Come on, we gotta make more money, have more boats out there.
Because you do have another rating there, all right? You have ampere hour rating too. And that goes very close to reserve capacity, all right? But they have the ampere hour rating. But you do have to remember, all right, just because you put a battery in the car with a higher cold crank amps doesn't mean you're getting a good reserve capacity battery. Again, same style, size battery. Many times, as the cold crank amps go up, the reserve capacity actually goes down.
Any questions on it? Okay, basic stuff. Now, battery testers, whether you have the snap-on type ones or any of these, the issue always is, I hear a lot of guys go, these things are not good. And forget about that little toaster thing. You know that little Milton thing that, you put your Pop-Tarts on or keep your hand warm? That's all it's good for. That is not a real load tester. Does that make sense? When you do units like this that are conductive resistance type, you got to be on the post of the battery. Remember what I showed you, the cable ends that are corroded? Too many guys go on there and they go, oh, it said the battery was good or the battery was bad when it wasn't. You got to test from a clean post. You cannot get a good test on a dirty terminal. Does that make sense? That's the big problem. You notice, by the way, Medtronics is picked. There's OTC, there's Schumacher, there's Snap-on. These guys were picked by every OE. Even when Interstate comes around, they're going to check that battery with their Medtronics version of it. May look different, but it's the same thing. Sears, whoever. They're going to go on the post of the battery. These are smart type testers. Conductive resistance is a good way to test the battery, providing there's not like a plate issue inside where you got like a collapsed plate. Sometimes you may get a little screwed up. But 9 out of 10 times this accuracy is in the high 90 percentile. It's the way to go. And it won't kill a battery if you're doing this out in your yard out there or your parking lot. If the battery's marginal, an old carbon pile load tester, the one that you're supposed to let go in 15 seconds that you had going there forever, you're going to kill the battery and not be able to get that car started to bring it in. Okay, so these are the ways to go. Now, when you look at series and parallel, it's something you should know with electricity. We just threw this in here real quick. When we want to use this in series and make two 12-volt batteries, you notice we go from positive to negative, and we're making it for a 24-volt starter. This you typically see on vehicles you work on, like what? Your diesel trucks, right? What are you trying to do here? You're running it parallel, negative to negative, positive to positive, so we could pick up what? Amperage. Okay? By the way, do not be a cheap bastard and put one battery in the freaking vehicle. Yeah, how many of you guys have one new shoe on? What do you walk around like this? One new shoe, one bad shoe? Okay? You're not going to do that, right? You're going to buy two. You got to tell the customer, if I only put one battery in, I'm going to have an issue. Okay? Especially with computerized charging systems. You got a difference of a battery that may be sulfated, resistance type problems, right? You're going to have issues here. You're going to need to call Rich then. Okay? So that's another thing here. Now, jumper packs. Get it, Rich.
Go back to that one for 1 second, Jerry. One thing. Jerry did say we use this to increase your amperage. In the two systems, the batteries being the same, all right? If you parallel the batteries, your voltage stays the same, your cold crank amps doubles. The amperage actually doubles. In series, the voltage doubles, but the amperage stays the same as one of the batteries.
And that's important. You may want to write that down. I don't know how many guys work on big trucks.
Does it affect reserve capacities or just?
Well, the reserve capacities on this one would double. Any of the amperage ratings would double.
Yeah, that's a double.
Right, that's a double.
Not on,
right, but not
not
the voltage would stay the same, amperage would double. Okay, on the other one, the voltage would double, but amperage would be constant. What one battery is.
Is everyone okay with that?
All
okay,
right.
Battery packs. Memory savers. I'm not a big fan of the 9-volt, and I forgot to take that picture again today. The 9-volt memory savers. You know, the one you put in the cigarette lighter and it pops out, and you just lost the radio codes and the seat codes. You don't want to use a 9-volt battery because what happens? 9-volt batteries tend to dip. Some of these gentlemen up here, as old as I am, maybe older, you old bastards, what's wrong with you, okay? Guess what? You remember the days of the first portable radio, remember? Listening to a Yankee game, 1 minute you hear it dies down, then it gets loud, and you're like, what's with that? 9-volt batteries tend to dip, including your amp clamps could be a major problem with 9-volt batteries in them. You need to check them. It will screw your readings up. Okay, so make sure you check them, even though the light may go, oh, power. How much does it take to power that little light bulb up? Not much, okay? So you need to check the battery. I had one with the light on, I just changed recently. The battery voltage would go 9, dip down to about 6 something, go up to 7 something, down. I put it on the meter to look at it. Then I graphed it. It was nicer to graph it, just to see that 9-volt battery. And that's common that you should know about. Memory saver like this to a good battery or battery pack is important. The way to go, all different battery packs. Battery maintenance for reprogramming. Super important, okay? Now, adjustable ones, like this one here from Actia, or we have one there from Midtronics that is standard but reprogrammable to change different voltages. Battery maintenance for program must be able to put out at least 13 volts. That's what most manufacturers look for. But they have to have less than 1 volt AC ripple. Remember we talked about AC ripple at the battery? If you interrupt programs because you have AC ripple going into that battery, okay, that's going to go through the system, isn't it? And that's going to cause a problem. So this is a spec that it has to have at least less than 1 volt AC ripple. Okay, so jumper packs could work good on some cars, but look at this example of a BMW. Requires a charger that can output 14 volts, and depending on the vehicle, at 55 amps. So if you're ever going to buy one, it's nice to see something like this that is adjustable. Make sure you check the specs out. Make sure it could even be more than just 55 amps. I noticed there's a lot of these out there. They don't put the amperage out. Oh, battery packs may not put the amperage out. There are some guys, other instructors that I've seen that go, don't worry about it. Just throw a regular battery pack on there. What's the amperage out of that battery pack? Is it even close to 55 amps? And then you wonder why you run into an issue. And how many of you guys here just for the hell of it are doing reprogramming? Okay, only a couple of people. Okay. It's a real good moneymaker. You need to get into it and not be afraid of it. You remember how many guys changed memcals and proms years back? Yeah, most of us. It's easier. You don't have to do any physical work other than plugging in and make sure you download the right program and, you know, itsy bitsy easy stuff. It's not that hard once you do it. And by the way, this keeps my buddy John real busy. John does tons of cars every single day. Check-in parasitic draw. Now, you notice I got my amp clamp here. And remember I said that expensive fuse in the meter? Okay. Expensive fuse in here. And I would say, if you came to my class and I actually seen your meter, or maybe we can look at your meters here, and I checked amperage with your meter. Ooh, did I just ruin the mic? Okay. If I check that, I bet a lot of your fuses are blown. That's very common in the industry. Okay? So, what I'd like you to do is, you notice here I got a wire. I got one of those little jumper things you put fuses in, right? I put a 10 amp resettable circuit breaker, or you could put a 10 amp fuse. So I'll blow that up for you so you can get a better look at it. So there it is, just that little carrier. I put a couple of ends on it. I put a circuit breaker, but you could put a 10 amp fuse in it. All of the meters tell you it's a 10 amp circuit. Some tell you it's a 20 amp circuit. It's a lie. There's not a meter out there that'll pull 20 amps. They pull 10 amps on air, but they can go up to 20 amps for about 20 seconds. So some of them are misleading. You look on it, Fluke is honest, and Fluke tells you it's 10 amp. I have some other ones. I'm not going to mention the names of the meters. I have a whole bunch of different ones, as you've seen in the beginning. 20 amps. Oh, read the fine print. Number one, it's not a 20 amp fuse in the back. It's a 10 amp fuse in the unit. It'll hold 20 amps for 20 seconds. Does that make sense? So be careful. Why blow your expensive fuse when these holders that you can get from CarQuest, Napa, Joe Schmo, whoever, they're readily available. That fuse is going to blow a lot quicker if you even put a 10 amp fuse in there. In this case of this, circuit breaker. Now, look what I'm doing here. I'm giving you a comparison of an amp clamp, and by the way, my battery was weak in this one. Okay? How much amperage with the meter in series meaning we're connected like we showed you before, the component is over there, we're in between it in a straight line. Okay? That's series. How much amperage am I reading on that meter? 14 amps, 140 milliamps. Now, let's go over to the amp clamp. Notice I have the amp clamp on the wire that's in series. How much amperage am I reading now? Now, here's the important thing. It is 14 amps, 490 milliamps. Give or take a little, it's not going to make a big difference. That's the headlights on in the car. Okay? The difference here is if we zoom up, do you see where the decimal is? And I bet a lot of you guys lose your mind when you try to hook your amp clamp up because no one tells you this. You notice the decimals there? That's not 1 amp. The reading, because of how you scale this, and if you own a PDI type clamp, what you need to do is go to the first click. The first click is actually 100 milliamps equals 1 amp. You just want to retag it. This is where you want to use this on low current. So if I'm checking a fuel injector, a solenoid, I want to do it here. Parasitic draw. This works good. Also, I always thought this was a piece of junk, but I made an ass of myself. I was telling guys, yeah, you don't want to use this piece of junk to show parasitic draw. I started using this, and I couldn't believe that you can get down to 10 milliamps. That's pretty damn small with this big clamp that's only tells you it's accurate. And I used to give you the spec on it, yeah. It says 400 amp max, so it's for starter draw, okay? And by the way, you can't break an amp clamp. It's only a magnet with windings in there, correct? The accuracy could be off. This is pretty damn accurate, just like I did this here. You could use these for parasitic draw. This is going to be tough to use for parasitic draw. Why? Sometimes I can't get around all the wires. I can't close the jaws all the way. If I can't close the jaws all the way, is the reading accurate? No. You got dirt from the brake blade or brake dust on there, ain't going to work. Got to clean it. Make sense? Okay.
What's acceptable parasitic draw?
There's so many of them that you really need to RTFB, read the frickin' book. You really want to stay probably nowadays, I would say, somewhere under about 40 milliamps. Most of them are very, very small.
Will it change if the computer times out?
Yes, we're gonna actually show you this in a second. We're gonna show you this. Computer times out are super, super important. You can get interference from drop lights. You could get interference, especially when you're trying to take an AC voltage reading. When a little bit after the break, we're going to have you hook your meters up. That's why you got wires, and be careful getting up. Wires under your chairs to hook your meter and your scope up. You want to say something? Yeah, you can just jump in.
I was gonna say, we have fluorescent lights up here, okay? Just like many people have fluorescent drop lights in their shop.
You guys see some numbers going?
See them changing?
142, a whole bunch of stuff. When you start putting this 200 and something, you start putting this near electronic stuff, you put a drop light near there, you're going to induce voltage.
Very sensitive.
Super, these are antennas, aren't they? You're going to pick it up. So a lot of you guys, how many of you guys use those metal cage lights that burn your arm? Still using those? Blow the station up light? No? We got rid of them, okay. Got rid of the burn the station up.
Fluorescent bulbs.
Fluorescent, but even those put a lot out. And by the way, if you have the fluorescent lights that have the plug, be careful near antifreeze. Like sometimes you're doing a water pump or whatever. I had a guy years back work for me. Some antifreeze went right in there. After that, we duct taped all of them unless we were using the plug in. It went right in where you would plug the receptacle in. The thing blew right up. So be careful, because antifreeze is a phenomenal blow-up conductor. It works real good. Now, here's something courtesy of Mitchell and General Motors to show you some normal draws, and in a second Rich will do some explanation here. I'm going to show you a little video that Rich has taken with parasitic draw, and you need to write down a couple of different notes as he's going through. Parasitic draw is probably the most misunderstood, A lot of people don't realize it. They're going to use some tools like this. Okay? You might as well take this thing and chuck it. Okay? But you're going to use this. This is common in the field. Okay? You don't want to use stuff like this, and Rich will explain and show you. He's going to prove to you. He's going to prove to you what you need to use for parasitic draw. Okay? You want to say something on this before I set you up?
All right. This is a chart, all right, listing parasitic draw for General Motors, all right, different systems on the car and how much they draw. And what you see here is normal draw. Let's say we say here 1.0 on automatic door locks. That's 1.01 milliamp. That's not 1.0 amps. It's not 1 amp. It's 1 milliamp. That's 3.6 milliamps. All right? Totaling them up, all right, will give you the normal milliamp draw on the car. All right? This will also tell you for how long. Timeout takes on that circuit 20 minutes. This one 20 minutes. A minute on this one. 15 minutes on that one. All right? Other cars may take a half an hour on some, an hour on some, 2 hours on some.
Some of those cars you'll be waiting a long time.
That's correct.
Okay, let's go to the video.
Go to the video. Let's go to the videotape.
Yeah, Warner Wolf. What happened to him?
All right, now, when we're going to start here, all right, just let fill you in. The car that we're starting on here, we're testing for a parasitic draw. The proper way. Testing for a draw. All right? I've already got the car set up and timed out. The car's been sitting for 2 hours. With the hood open, the doors closed, everything, the hood light is disconnected. Any alarm switch that's along the edge of the door, the hood rather, or whatever, is disconnected. All
That's
right?
important. A lot of times you leave the bulb in the hood or the door open. Make sure you have that stuff off.
Okay. Everything's been closed up. Everything is shut off. All right. I have a battery pack. I have a multimeter. All right. And it's already set up on the car here. I'm going to run over now. I'm going to start hooking this up. All right. The first thing we're going to do is we're going to take the negative and put it to of the jumper pack, put it to a good ground somewhere on the engine. All right. The second thing I'm going to do is I'm going to take the red lead of the jumper pack, hook it up to the red lead of the multimeter. Now you see the multimeter is on common and amperage, 10 amp scale. I'm going to take the negative. I'm going to hook it up to the positive side of the voltmeter. Now I'm going to turn the jumper pack on. As soon as I do that, you'll notice the meter activates. All right? What's happening here? I've paralleled the original system of the car. I've paralleled the battery system of the car with a jumper pack through the multimeter. And what you're seeing here is you're seeing a reading of amperage, and that's just a flow between the two batteries because they're never at the same voltage. All right? You're seeing a flow. You want to see that flow. Doesn't mean anything. All it means is that that means that it's connected. Now,
Rich, if we've seen 0, 0, 0, we would have what?
Either a blown fuse, a bad connection. You got to see something.
And he was connected to the alternator.
And I was connected to the alternator. Now, I disconnected the battery. I've got 0. I've got 10 or less milliamps or less. All right. So I've proven now that this car does not have a battery drain. Okay. Now again,
now you're reading the drain on a jumper battery.
it's draining through the jumper battery.
Right.
Now I just went and turned the parking lights on the car.
What's he reading now? 400 something amps.
No, 4,320 milliamps. That's 4.32 amps. Your parking lights are on.
And those bulbs pull somewhere near an amp each, right?
You see the
Depending on the
decimal,
bulbs in the car.
decimal points in the middle here. Now I'm not on the milliamp scale. I'm on the amperage scale, 10 amp scale. All right. Now before we did say also if you turned around and had 0, all right, is a possibility that both batteries are at the same voltage. Go in and turn the lights on in the car when you're first hooked up. If you had a reading, then you're hooked up okay. All right? Turn the parking lights, we went back to 0. Now I'm going to reconnect the battery. All right?
Now, by the way, putting the cable on or off, you should always put a little pressure against the cable like this and come off quick, rather than, you ever see the lights flickering on and off? It's not good to do all that spiking.
Yeah, if
Put
you
clear off, put clear on.
if you have the battery, go ahead.
Keep going back to timeout situations with the...
Watch, he's going to get to that. Good question.
All right? Now I'm disconnecting the system. Okay?
So now he's taking the battery pack out of the picture.
Out of the system. All right? Now the battery's reconnected. All right? You haven't disturbed anything in the car for
So
this whole
nothing yet
test.
went down.
And if you had to change the battery, you hook everything up this way, you're away from the battery, you could change the battery, put a new battery in, re-hook up, and you've done a memory saver while you change the battery, and test it for a battery drain at the same time.
Good way to change batteries, right?
Now,
Or the lugs underneath. Sometimes you can't get the alternators, go to the
Alright.
lugs.
now we know that this car, I set up the same, I've just changed it around a little bit. I'm going to use the multimeter. Put the volume down on that.
So you told me it had no volume. You lied to me.
Okay. All right. Here's what we're going to do. We use the multimeter. All right. Disconnect the actually the test light. All right. Excuse me. All right. And we're going to do what a lot of people do. We've
Look at that bright light.
We've proven that this car has no battery drain. What would we do? We disconnected the battery, put a test light in, and we said, somebody's saying, well, gee, I just tested for a battery drain in this car, and this car's got a battery drain. Look at that.
And how many of you would do this and look for a drain? Probably most of you. Okay? But you're not going to do this today. It's okay.
That's what's
What are you
happening.
here for?
A lot of people are still doing this. All right. Now, that light, some people are telling me, well, it'll go out after a little while, or it'll get dim after a little while. No, it won't, and I'll prove that. Okay. That light will stay on if you left it there till the battery went dead.
Very little amperage that bulb takes. It's like a Noid light. A fuel injector doesn't work real swift, right? Just because the Noid light lights up, all that's telling you is it's able to light a couple of 100 milliamp bulb up. It doesn't mean it can open up an injector at about 1 amp, can it?
Right. All right. So now let's go out of this, and I'm going to show you why that bulb's never going to go out. I'm going to do the same thing, all right, but I'm using a multimeter now.
And
Now,
pay attention to the meter.
I've got it all hooked up. All I've got to do is take that, just like I did with the tip of the, I'm hooked up to the battery cable. I'm going to take that tip and hook up to the battery. Watch the meter. When I first hook up, watch the meter. Look how fast it goes up. 450 milliamps for a split second. Then it goes down again. You can't get 450 milliamps through that bulb. Now I'm going to reset it.
Now
all
watch
right?
this. Look at the
And
meter again.
each time you do this, you never know what systems are going to reset themselves. I pulled it off, look at it, went over 3 amps.
So it's charging up other parts of that circuit in the computer.
Different systems will come on at different times.
Right, you get a discharge from like caps or something in the...
That's
in the
correct.
CF, and
Absolutely.
And now you're powering them up.
Absolutely. And now you have to repower the system up. All right. Now you'll see it eventually will go back down because I didn't open doors or anything on the car. All right. And it will go back down eventually and shut off. But it can never draw that amperage through that light. It has to see the high enough amperage in order for everything to time out. And if it doesn't time out, that light will stay on until the car goes dead. And you could think you have a drain forever. And there is no drain.
Now a question. What, on a real car, when we do this disconnect, what's the problem when I disconnect the battery? What am I missing here with a parasitic draw? If I disconnect the battery, what releases? That could be a problem. You ever work on Fords? What happens? Relays stick, don't they? When we do that, we lost that relay that was sticking. We may not see that relay come back and stick again. It's better to use an amp clamp. This is a right way to basically do it, but you really want...
No, this is, Jerry, this is not invasive in the system at all when you use it, when you parallel it through the meter to begin with.
Oh, yes, okay,
What
you
you're
have.
saying though is to leave the original battery in and then break it and just leave the amp clamp with a minor flow, right? And then this way the relay's not gonna drop
No.
out. You're gonna.
Well, with his
the
battery
ground's
pack,
through-
with his
through
battery
small
pack,
wire.
he's not gonna do that, but
No,
again,
right.
it's a lot easier
Oh,
to do
yeah,
this.
if you could put an amp clamp on it, just on the
Done.
cables,
Right.
all right, you haven't disturbed anything to begin with. Neither way will you disturb the system.
Right.
Now, the
Okay.
other caution there is when you're using the meter, Johnny turns the key on or someone goes over the amperage, you're gonna pop your fuse.
Absolutely.
I like to work smart, and you guys are always in a rush. An investment of $100 to go like this around the wire and not second guess blowing something. Remember, you're using this as a conversion in your meter voltage jacks to see the draw. Does that make sense? Or you got a Vantage, or you got a scope. We could graph it all out. You could walk away for hours. Because some of these things are going to take hours. Get some of those Fords. Rich gets called out sometimes. It's going to take a long time. I can't stay here for 3 hours. Okay? So I say an amp clamp is the way to go. Not that that's wrong. That's right. You got to show you the basic way of doing it, but work smart. You need to invest in things. I noticed some of you guys have quite a few nice tools here that we're going to be hooking up very shortly.
Who makes that amp clamp, the big one?
Their PDIs are pretty, you can get them through TST. We sell them, they're about $100 a pop.
And they're accurate that low?
Yeah, pretty good. I have a Fluke EDI-110 that's about a $480 amp clamp. It's real close to it. I can break 4 of those and have $80 to go out and have a beer.
No switches,
And no
no nothing
problem.
on it, just coil and inductance in there.
Yeah, it's just, they're pretty accurate. All the stuff is,
On and off, or different ranges, and a zeroing button.
this has a zeroing type wheel. You know, it's not bad, not a bad clamp. This has the little button. You gotta be careful. The buttons, I'll tell you, because I've used a lot of these for different years.
You lay
This
it
button
down,
seems
hit
to
the button.
stick. Huh?
Doesn't matter if you lay it down and it hits the button.
Hits the button. And by the way, sometimes guys try playing the game of switch the wire negative to positive when you have it on wrong. It skews the reading. You want to take it off, make sure you're on the right way and hit it. I've used these for years, so believe me, make sure you're on the right way. Okay, let's move on from...
No, he actually.
He answered the question? All right. All right. Let's take another vehicle with this burning computers. All right. Again, I got called as a referral from John. All right, for somebody who had a 2000 Volvo C70. Same exact problem. All right. Again, I broke out my ohm meter and started checking resistances, all right, of all the output circuits of the ECM. All right. When I got to the O2 heaters,
The heater, not the sensor part.
all right, the heaters, which are controlled by the computer, they're grounded through the computer. All right. I found that the rear heater, the rear oxygen sensor heater, downstream was 70 ohms, but the resistance on the front heater, the upstream heater, 6 ohms,
Low resistance,
high amps.
so we could have used an amp clamp as well on this, right? Can we just click? Real 1, 2, 3, there's 4 wires there. Can we click on it? 2 of the wires, one's going to be power, 12 volt, one's going to be ground. Or, again, Rich is showing you, you could still use an ohm meter to do it. It
That's
proves
right.
Ohm's law that we started with.
And if I find a problem, a close problem, that might be a problem, if I think it could be, I can do the other test. I can do the amperage test. Maybe, as it warms up, it gets worse. And how is it going to warm up? By feeding it amperage. Okay? Letting the system work. All right, that amperage is what causes that.
And think about this, you know, Rich's method with an ohm meter, I'm not a big ohm meter guy, but this is, it's a good idea. How many of you guys have taken or seen a lot of like Dodge Caravans or some Hondas that had low resistant injectors? The resistance of the injectors were low. You may have done a motor swap, because I've seen a lot of cars come in that did motor swaps. Ford Tauruses, they had 2 types of injectors, one low resistance, one high, same motor. You put it in, pops the PCM. You burnt the circuit on it. Of course, why? Before it had high resistance injectors in, you put low in. How about even if you took your ohm meter and you quickly checked parts to see if they all had somewhere near the close resistance? This is what dealer stuff did for years. So before you put that new solenoid in, is it actually good? That's one way to do it. Now, I personally take a power probe and my amp clamp. I put the power probe on the side, that's going to be the feed side. I put the black lead on the other side, put my amp clamp, I hit the power button, I see what the amperage is. Couple hundred milliamps, it's good, it's going in the car. Make sense? Pretty quick. But you should do either one of them. Does that make sense? It's nice and easy to do, and then you know you got something good going.
All right. Oh, by the way, an upstream O2 sensor and the third $1,200 computer fixed the problem. Okay?
Someone was hurting that day, huh?
All right?
A
Now.
lot of money.
Yep. All right, let's get to an O2 Jeep Grand Cherokee. All right? I was called to check a power door lock problem. When I got there, I said, well, I'm checking the power door locks, and I said, well, you know, and of course, just for the heck of it, I check everything out there. I turned the key on. Wanted to check everything. The power windows didn't work on the car. I confronted the shop owner, and I said, you know, you called me for a power door lock problem on this thing, and you know, the power windows don't work also. And he told me, he said, the customer said, I only have a problem with my door locks. So I went back to the car and I said, well, let me at least test that. I went there. I found in the passenger side door, going to the passenger side control module, the door module, which controls all of the car except for the driver's door. But it does control all of the car from that module. I found the main ground wire broken in the hinge area of the door. Now they use about a 12 gauge wire, but the strands are very heavy. And if you ever repair these things in cars, all right, and you ever try to just put a butt connector or something in them, you know, you'll
40 days.
you'll have a
You'll have it in your butt in a little while.
a little
so it's gonna happen
while.
when it
What I
comes.
do is I usually cut these things a little short, all right, and I use a piece of high-stranded wire, all right, and I not only just run it across, I loop it, okay? I loop it and I use high-stranded wire, and I put it in with AVP connectors, which is similar to a butt. You could use a butt connector at that point as long as it's not in the hinge area itself, but as long as you've got a piece of high-stranded wire in there, all right? And so I fixed it, and actually it fixed every problem. It fixed the remote not working, it fixed the door locks, it fixed the power windows, all right? So that was solved. However, okay, got a question and answer here. One, if the repair had only fixed the power door locks and not the power windows, one, would you have tested the power windows anyway? Who would have?
Just a switch to see if they go up and down.
Check everything.
No, for what was wrong with it?
Diagnose it.
Diagnosed the power.
Customer didn't want it.
Okay, yeah, you know, different shops will say different things. Nothing's right, nothing's wrong.
But the
If-
thing is, we're out to make money,
That's-
and if you didn't identify there was a problem, like Mr. Smith, you got a ding in your front hood that looks pretty new, I want you to know before I work on it, because you know what? They're gonna say it's your problem. That door lock, I brought it in for the window, or whatever he brought it, window, door lock, how come that don't work now? If you didn't tell them,
That used to
That's
work.
right.
it's gonna be on you. 'Cause they, you know, they're gonna, some of them are not even lying to you, they're just busy.
Just
Well,
don't care.
They may
just don't know.
not even know, because when you close that door and those two wires touch,
That's true, that's
Like-
true.
like-
you're opening the door and you're trying it, they never do that,
Well, if
they're
that-
in the car
It
trying it.
depends,
That's
because,
right.
again though, in this case, if it touched when the door is closed, everything would work. There's only one wire,
Right.
okay? So there, and they complained about the door locks, all right? And do you think the customer knew that the power windows didn't work when he brought it in? And again, the same thing. As Jerry said, some may not have known, all right? But I would say, in many cases, they do know.
Did you
So
hear
be
that little-
careful.
Did you hear that little clip where that lady called OnStar, she can't get out of her car, the door's locked? The lady hit the button. Okay. I mean, some people are really oblivious to what's going on around them. They don't check stuff. And you're right, that door, maybe it worked, you never know what it is.
Multiple wires breaking
Correct.
in that.
That
particular
happens.
model.
Oh, it's definitely
And how many
happening.
of you guys are using, years back I had to use a Polaroid before digital cameras. I would take pictures of stuff, even doing a valve job or something, because they have no clue what you're doing. You show them pictures. Now with a digital camera, you can put a slideshow up for them, okay? You know, take the little card out and they'll flip all their little pictures and go, look, here's what I did to your car.
Heater core.
Oh,
yeah,
Do
absolutely.
they realize how you're killing yourself on a heater core or a, you know, an evaporator? They don't have a clue. They just go, well, how come it's that much money?
Right.
Get your ass under that dash. How about that?
Invite the customer in when you got a Jeep evap you're doing, then they appreciate it, and then they don't have a problem dishing the money out when you tell them it's all set.
Well, that's it. You do have to show them.
And, you know, and sometimes they may hold you to book time, and sometimes we know book time is not exactly right, depending on, are there rusted bolts, is something broken, was someone in there before, rigged something up?
Drilling
It's a nightmare from hell. So again, digital camera, you can get them dirt cheap. Start taking some pictures, man. It's the way to go.
Right.
Remember, paper and pictures sell.
Yeah.
They sell. Make
Even
money
these,
with them.
even
How did the
these,
shop owner handle that?
I couldn't tell you.
I used to print everything out. I mean, years back, even my Snap-on MT2500, I'd print stuff off that, one for me, one for my customer. I'd use my state inspection machine with a little device I used to plug in so I could wire the cable out to the machine and to me so I could print a whole bunch of stuff out. I didn't need to buy another printer. People see that stuff, they'd go, whoa, it's impressive. And I printed off my Tektronix 222, my Fluke lab scope, my 97. I printed off all these things and gave it to them. It's always nice to play that comparison game or show them, here's what it was before and here's what it is now. It's nice.
Once you put it in writing, they believe it.
Yeah. Well, come on, you go to a doctor, you want nothing going on? Okay, you want something.
And I'll tell you, I have a little video camera, very small video camera, and a lot of
Video crazy now, this guy. Watch it when you go to the bathroom.
And I'm going to tell you, as a matter of fact, some of the pictures that are up here actually are takeoffs directly from the video.
And he came out good.
Oh yeah,
We took him off and
come off the video.
worked good. Okay, so electrical circuit's going to give you a break in about 10 minutes. And then the latter part, which is going to be quite a bit of time, you're going to hook up your meters and scope. Right now, let's look at a full electrical circuit with 2.1 volts per cell. Okay, that's 12.6 volts that battery has. If the bulb is good, how much is the voltage right here from that 12.6 battery? Right there, bulb is good.
Fellas, figuring the right side, upper right, is positive.
This is positive.
Okay, it's not marked, but right, upper right side is positive.
How much voltage will we have right here? How much will we have here? The bulb is working. How much do we have there? Do we really have zero? No. We have a very small amount, right? There has to be something over there. Now, how about an open circuit? By the way, no one has ever come in your shop and said they had an open. They all had shorts, right? Doesn't matter what it is. It's an electrical problem, it's a short, correct? Sometimes even shops that brought cars into me, you know, the component don't work. It's a short. You go, how do you know it's a short? And is it short the ground, short the power? I don't know, it's a short. Short is a generic term out there. So here's a open circuit, which is very common. What would current flow be in this circuit? Open. Zero, right? Now, battery's still 12.6 positive terminal. The switch is good. There's not much of a voltage drop here. How much voltage do we have going to this bulb right here?
Battery voltage.
How much do we have here?
Battery.
How much there?
Battery.
Good. You would have, voltage is pressure, we would have that 12.6 volts or thereabouts right there. Obviously here we would have nothing. Okay? Yes, sir.
That test works backwards in a lot of clutch coils like compressors and stuff. If you're looking for a ground and you don't want to pull a wire off that compressor and you know the other side's grounded, shut the key off and see if you got a ground on the other side. It'll save you a lot of work digging those wires off the compressors and some of the other stuff. So that also works on a ground circuit.
Sure.
If you know that you got ground on one side and you got a basic component there with a coil in it like a solenoid, you can save yourself a lot of time by just triggering, following the ground back. You're going to know that you don't have an open circuit there and that part is already in the circuit instead of going the other way and testing.
And, you know, again, that's where a power probe really comes in handy. You can use a whole bunch of stuff with a power probe. Just be careful if you're using it on a computer circuit. Know where you got to use it. Don't just randomly go, yeah, I go put power over here and ground there. I mean, you're going to run into problems. That's stupidity. But you got a bulb not working in the back of a truck or a car. I'm going to go back there with the power probe. I'm going to check, number one, without pressing the button, do I have power or ground? It's a little voltmeter all in itself, isn't it? Okay? And then if I have power and no ground, I apply ground, it lights up. I got a problem on the ground side. Okay? It's not that hard. Now, a short to ground, what happens here? Okay.
What size wire?
It's a smoke show, isn't it?
Doesn't make any difference what size wire.
And years back, how did we find these shorts? We took a little tin foil and looked for the smoke, didn't we? Wrapped that glass fuse. It was okay back then. Can't do that nowadays. It's going to be very, very expensive if you dare to do that nowadays. Now, there's also another short, a short to power. Okay, a short to power, the lights are on, and maybe the horn starts blowing when you do that, or you blow the horn and your lights come on. Wires rub together, they could be an issue. Here's a couple of different pictures here. You got broken strands, and when you want to look sometimes why these things break. Sometimes they're too short, they routed them the wrong way. When you see a burnt connector, what's going on here when you see a burnt wire connector? Where you got a short. And by the way, on a car, what is like an intentional short to ground on a vehicle? What do you think of, like wintertime? What do you have on your car? The rear window defroster, right? And how many times have you get Alkin back there? I've come across quite a few cars where the ground side, the bolt was stripped. You know, at the factory, the guy was like, wah, it's Friday. He's not paying attention. He strips that, just like sometimes you use those air guns and you just go crazy with them. Can't see it from where you live. Now, what happens when we have a poor connection? It's Alkin, it's heating up. I've seen some cars in the back where that little plastic panel junk they have start to melt up. Okay? Why? Because that thing was Alkin and creating a lot of heat. And of course, the rear window wasn't clearing too good, was it? Because it was arcing right there. So that's another one. So here we must have something that this is melting, shorting out. Okay? And that's a brake pedal in the background, by the way.
Because you've got the burnt wire going in and the burned wire going out.
So you need to investigate, not just clip the wire and go, I'll make it look pretty, tape it up, plug it in, I get the same problem.
You got a green headlight with terminals, and you just put a plug, you better change both ends on it, make sure you got everything new.
Now here's a good one that Rich had, and I really like this. I'm going to blow this up. I put the terminal in Rich's pocket one night. I said, don't lose that thing, because it's really good.
I still have it.
You still have it? I
still
thought it
have
went in the wash by now.
No, it's clean enough.
Now, look what happened here.
That's it.
Look what happened from this terminal that's connected to this post here. What happened to the battery? What do you think caused that melting? Heat, current flow, arcing. But what's the problem? What are you going to do? What's causing that? You gave me some of the things causing it, but what are you going to do to...
You're going to clean that terminal, tighten that terminal. That's the two biggest things.
Clean and tighten, right? That's what you would do? Is that correct?
No, because connected to get replaced.
What was that with the connection?
You're not going to replace it because it burned.
Do a voltage drop on that.
Ah.
Bingo.
That's toast.
High resistance, right?
High resistance right in there.
And we found out why. It's really not real visible here. But if you look at the connector carefully, when they made it from the factory,
This was never touched by anyone but
never
the
touched
factory.
the factory connector, they never completely stripped the wire.
So insulation was on part of it.
Rubber sticking out all around the connector.
I see that down at the other end on the motor.
Oh, yeah, they do.
Yeah.
They do.
Sometimes, well, you know, it's done by a machine. The machine goes in, cuts, and pulls the wire. It cuts the wire, strips the wire, and if it doesn't strip it, the knife that they're using, the stripper that they're using, could get dull. It may not
Someone
strip
didn't
it.
change the blade. You know, it was Friday. They
Yeah.
want to go home.
There you go.
Machines are even in the union workers nowadays.
Four starters don't want to know if they'll start.
Oh, that's it.
And there's another connector burnt up. Look at that. Got to have an issue there when we see this type of problems.
Right.
Just other connectors would burn stuff.
That's-
And look at this alternator connection that a lot of guys really don't pay attention to. There's a major, major issue. Remember, the charging system on these cars nowadays has to be really up there.
140 amps.
Okay?
This was an
And-
aftermarket connector that had been put on the system.
And poor connectors, you know, when you buy electrical stuff, some of the guys were saying last night, I guess there was something going around, a bulletin on some of the connectors. They're made in China and stuff.
Yeah.
It's almost like the sheetrock that you probably heard about in the news. People got to get rid of their house because the sheetrock made in China is dangerous and gassing. You guys heard about that? Well, same thing with some of these connectors and wire. You got to be careful that you're buying something that is a quality product. You put that crimp connector on, something like this, and you're going to run into a problem. And because you did it and you said it's new, you're not going to go look back there. And all of these are not right in your face anymore, are they? They're buried in, you ain't taking the cover off or bending your fat ass over the fender anymore to go look down there. You figured, hey, I did it, it's done, screw it, I got to go look for the problem elsewhere. Always go back and look, and again, make sure you got quality stuff.
The Harbor Freight was putting out fuses, right? And I'll tell you what, I ran into one.
What would they put in that? I'm sorry, because I laughed.
The
but-
wrong, the fuse rating was not.
We're going to get to that in a second. I'll show you.
We've had that.
I'll show you one in a second, watch. Very good. Transmission pan, you've probably seen this one, Mike, on the caravans, where these rub against,
Wiring harness.
the wiring harness melts up.
No, I see it more where the start, the mount, where you go, there's the starter and it goes over.
That's another one, but the pans are common.
Yeah. The harness drops down.
Especially when oil leaks on us and all the wire gets mushy and it rubs against.
Brandy fluid at that point, because the solenoid pack can leak.
Leaks like
There you
me.
go. Yeah.
A fine made in Italy product. Okay, now look at this great fuse that Rich had. Okay, this fuse was wired up like that.
Yeah. It was blown.
Blown.
And they just kept saying, well, if it blew a 30 amp fuse, we got to make it a little heavier. So
make
let's
it
just
40 or
wrap
50.
wire around it. And that's exactly how it pulled it out of the car. You have to remember something. Today's cars, because they're lightening up the cars, making the cars lighter, they want to use thinner gauge wire. It's very
It's a
thin.
lot of weight on a car.
Sometimes you look at some of these wires, it looks like there's about 5 hairs inside of them, and that's about it. All right, very thin wires. Be very careful about what fuses you put in. And we were talking, this fellow over here who said something about some imported fuses.
Here we go. This fuse
All right.
still works, by the way. It melted, but it never popped. I have that in the training center. It still works. Anyone want to buy it off me? I could sell it to you.
And I'll give you,
It's a good 20 amp, still goes.
a little story, quick little story, all right? Looking for a short in the car, there was blowing a 30 amp maxi fuse under the hood of the car. 30 amp maxi fuse, tracked it into the fuse block in the car, and all it was a 30 amp fuse feeding in to 4 15 amp fuses, okay? It was blowing the 30 amp maxi fuse. I finally went on each line and found one of the 15 amp fuse. I felt it saw it go into the block, and I said, how can the block, it's plastic, how can the block be burning up this fuse, it's burning the 30 amp maxi fuse out. I finally found that coming out of this one of the 15 amp fuses, if I pulled the fuse, there was no draw, no short. I plugged the 15 amp fuse in, it would blow a 30 amp maxi fuse. I pulled the 15 amp fuse out, and the 15 amp fuse was so thick inside, all right, it was handling more current than a regular 30 amp maxi fuse.
So again, buy quality, you know,
That
the
ain't
guy
right.
comes around with the van selling you the cheap
That ain't
crap.
right.
Double slit fuses.
Don't do it. You're really gonna run out of
Be
that's-
careful.
These
Be
things are
careful.
real.
Be careful,
Short to power, wires heat up, they touch each other, that's how you would get a short to power.
right?
So always look, again, your eyes, your brain, your eyes, your ears, your nose, your hands, most important tools. Sometimes you gotta wiggle, jerk, feel, massage the wiring harness, and something may go out on a car. You may also want to get a short tester. You could buy something like from our great sponsor, Power Probe, and use a short tester like that, or some of the other little ones that are out there with the little needle bounces, right? Or, years back, I found my old thing, we had to make this when I was in working for Ford. okay? A 6014 headlight, a flasher, and a little buzzer, and that loads the circuit up real good. How many of you guys ever worked for a GM dealership where they used to tell you if the ignition coils on that GM, you had a misfire like on a 2.8 or a 3.1, you know, where they have the coils that plug right in, you got the module thing there? Their thing was take a test light, go to the 2 pins, one negative, one positive. If it triggers to light this up, it's good. How much amperage did this thing pull? How much does a coil pull? If you light a headlight up, that means that module and the driver were good. Why? Headlight's going to pull 6+ amps, isn't it? This is going to pull milliamps. So you can't go by this. Some people, you heard John Anello say many times when he's taught, a Noid light. How many guys put Noid lights in there to see if the fuel inject is good? A Noid light is a couple of 100 milliamps. An injector needs 900 milliamps to operate properly at least, okay, not go over 1.2 amps. And it needs about 700 milliamps to just barely open. 200, a light flashing doesn't mean anything. Just means you got some power and some sort of ground. The ground may not be good enough in the computer. The driver may be weak or burnt. Or maybe the ground's going in or bad. That's when you need to do a voltage drop. Questions? Okay. And do this burnt block, and I think we'll take a break.
All right, all right. This is a very popular
I lie on these
problem,
brakes, I'm real cheap, I'm sorry.
very popular problem on Volkswagen. I could probably say that most people have seen this out there, all right? I got called on this after the repair. The shop had already repaired the car. They put a brand new block on. They
Yeah,
put
you
a
can
brand
still
new,
talk.
sure, they put the brand new block on, okay? They took the terminal, all right, it's all factory. They cleaned it up, all right? They put it back together. They ran the car. And he said, you know something? He said, I just wanted to see, when I went out there, if it was still getting hot, because I could tell it got hot. And he put his hand on the thing, and instantly, all right, got a little burn mark on his hand. All right? He called me up, he says, this thing is still getting hot. So I said, all right. I talked to him over the phone. I said, do me a favor, take a voltage drop test. Now we're getting into voltage drop here. Voltage drop test. I said, give me the voltage drop between the terminal of the alternator and the battery, because that's how that circuit goes. There's the battery, comes right in, goes through that main fuse, that's a 100 amp fuse, all right? And that wire goes directly out to the alternator. That's the alternator wire. I said, give me the voltage drop between the back of the alternator and that battery terminal. He said 0.2 of a volt.
Good or bad?
Not
Not bad.
Not bad. 0.2 of a
is
volt
not bad.
is not bad in an alternater in a heavier amperage.
Remember, it's
While
not a
charged.
computer wire.
Right, it's not a computer wire, all right? 0.2 of a volt. I said, well, 0.2 of a volt is fine. He said, well, how come it's getting so doggone hot? I said, all right, let me come out there and see, all right? I went out there, I took voltage drop readings, rechecked him, 0.2 of an amp.
A volt.
I'm sorry, 0.2 of a volt, excuse me. 0.2 of a volt, all right? What I did is I worked closer and closer to this terminal, all right? Now, a lot of people would say, all right, they probably, the stud, the nut, let's retighten it some more, okay? And I thought, because that terminal, that nut, that stud was what was really felt like it was really getting hot. When I got to the eye, I put my probe about 1/8 of an inch into the wire behind the eye, and the other probe on the eye itself. I had the same 0.2 of a volt. So 0.2 of a volt over the whole length of the wire is fine.
Resistance, right? Wire's resistance.
Right? Okay? 0.2 of a volt over the whole length of the wire is fine. But when you get 0.2 of a volt within 1/4 or 1/2 an inch, 0.2 of a volt drop,
Too much.
way too much. The heat that's going to develop from that is going to burn anything.
It was playing a little Hawking game there because it was that close.
And the problem was the actual crimp itself to the wire. All right? Now this one didn't have insulation in there either. It was a factory crimp. I actually cut, there's a very short wire. I actually cut right at the end of the crimp. It didn't have any play in it because it's into the harness right back here. All right? I went right there. I freed a little excess play in it. All right? I put a good solid connector with my big crimpers. All right? Got it on there. I put it on, tightened it up, let that car run and crank that alternator up, and you could put your hand on it, it wasn't even getting warm. And that's clear that, yes.
Strictly complaining about temperature, the circuit was still working, correct?
Oh, correct.
Yeah,
It was still working. Oh, yeah.
By the way,
As a matter
rather
of
than
fact-
burning your hand, could have used a temperature
Yeah,
gun,
yeah.
right? Your little infrared thing.
And remember, it's not going to heat up if it's not working. Just the resistance alone isn't going to allow anything to heat. You have to have current flow through there to create the heat.
And when we talk about voltage drops, when you come back from your break, you have to have the circuit working. Give you some tips here on voltage drop because this is some of the stuff you're going to be checking. Here we have a voltage drop using the power probe. We're checking the starter circuit like here, but the real world is the battery's not right next to you, right? It's up under the hood. Sometimes a pain in the neck, the leads won't reach. Take your power probe, connect negative and positive to the battery. Take the little wire that comes off the power probe, connect it to the tip. Press the button, make sure it pops the breaker. If it doesn't pop that 6 to 8 amp breaker, you don't have a good ground. Okay? Once it's popped, undo it, click it back, bring it down under the car. You notice here, the red little light's on. I'm pressing it. This becomes my positive battery post, okay? The tip of the power probe, my red lead from the meter. I put it on voltage drop. I go to the positive terminal on that beautiful corroded starter, okay? How much am I reading for voltage drop? And you're going to see why we're doing this. Again, you're going to be using your meters and stuff. We're going to be generating signals in a matter of minutes. What am I reading? What scale am I on? Okay, for you blind bastards out there like me, I'm up here and I can't even see, for Christmas sake. Okay, got 12 volts, 0.96. What am I reading? Another way of saying 0.96. By the way, how do you call Identifix, a great hotline or someone, if you can't tell me right now? You know what this is. It's number one. What scale are we on? The 40 volt scale. 0, 0, meaning you can read everything from 10 volts up, right? Anything on that side of the decimal. This side of the decimal here, it could be 1 volt, 2 volts, all the way up to 40 volts, because you got the point there. 960 millivolts. There's an imaginary 0 at the end here. That means it's almost 1 volt. Good or bad voltage drop on this vehicle? Feed side, bad. What's going to happen down the road, right? You're going to run into a problem. Now, we take that little wire that comes off the power probe. We're now checking the ground side of this circuit. And just to show you, we're on the ground. You got to dig in. You got to dig in here. You know what usually happens with dissimilar metals. You probably see a lot doing trannies and stuff. Steel bolts going in. A lot of times when you hear click, click, and you're ready to put a new starter in, you go, to put a new battery in, you then go, oh, needs a starter now. You take your little air ratchet, right? Unless you're a wuss and do it by hand. You go, boop, boop, right? Take it out. Get the new starter. You don't clean anything up. You throw a new starter in all nicely painted. You zap the bolts back in. You cleaned up some of the voltage drop, didn't you? It works for a little bit. And then what happens? Mrs. Smith comes back in with the problem because everything is still corroded. We needed to clean that area up with your little air buffer doohickey, like your little DA, right? Clean it up, clean the bolts up. 9 out of 10 times, and you can see how bad this is. That was the positive post, okay? This is a police car in New York City. We got how much voltage here? 320 millivolts on what scale? 0.4 volt scale. because the decimal is not here. That would be the 40 volt scale if it was there. Does that make sense? So between 920 millivolts and 9 volts, is that starter getting 12 volts really? And by the way, you need Johnny up top to crank it over. You don't do a voltage drop unless you crank it over. Does that make sense? Otherwise, you're not getting an accurate reading. Super important to make sure that you know you got to load that circuit up. Any questions on that? Good. And if you do have a question, you can always ask. Voltage drops. These battery posts, you need to dig in. Battery terminal, and we talked about the problems there. Where to go with your meter, how to hook it up. Okay? Stuff is in your handout. I want to spend a lot of time. A wire size amperage chart and maximum amperage. So we gave you this chart. You can see 14, 12 gauge, 10 gauge, 8, 2 gauge. Look at the difference in feet. The maximum for how much of a drop?
3%.
3% drop.
And that's you get an amperage down the far side. All right. For example, just give you an example. If you're going to put 1 amp through a 14 gauge wire, and you want less than a 3% drop, you can go as much as 45 feet. That's 1 amp. Okay? Everything else going through a 14, if you're up to 10 amps in a 14 gauge wire. No, 10 amps on the far side in a 14 gauge. You go to 10 amps through a 14 gauge wire, how far can you go with that? Only 4.5 feet.
Not far.
Not far. And that's a 3% voltage drop. All
So
right?
it's a little something we gave you there. You may want to write a couple of notes down there.
You have the chart in your book. I know it's kind of small, but you have the chart in there.
And remember, never undersize a wire. How many of you guys use heat shrink and solder? The heat shrink with the solder in it to connect wires? Works real good. Okay, just make sure you strip the wire back far enough. It's in there. And when you're heating up the heat shrink, okay, be careful of other wires. You should put the metal plate on your little heater. I know some guys don't do that. They melt all the wires. Car didn't have a problem in that area. Now it does. A little short the power going on when you melt the insulation. If you don't have one of the shields, make sure you get a bunch of aluminum foil to put behind it to deflect some of that heat away. Okay? Because I did ask, someone asked about, I think it was you probably, we asked Rich about soldering. Okay? Any connectors that go to a computer end, if it's crimped, and be careful using an electric soldering gun. You can trigger a lot of things. What does it have? It's a big coil with windings, right? Years back I used to take in a distributor and press it. I can make the coil fire. I can induce the coil to fire in there. Okay, so I like using those little propane soldering things. They work real good. You don't run into problems. Okay, they work well. Any questions, comments? Okay, this is important. Voltage drops, loose connections, corroded connections, undersized cables, broken strands, bad connectors you may want to put there, okay, all equal low voltage, low current at the loads. Super important to understand voltage drops. And by the way, is the biggest problem in any electrical circuit on the vehicle is a voltage drop. It's probably the most misunderstood. And most people go to the power side of something. What do I mean by the power side? The B+. They forget all about the ground. The ground is the side that's going to screw you. That's where I found most of the problems. It's easy to check for 12 volts with your meter. You spent big money on your meters, didn't you? It becomes a glorified test light. All you're doing is checking 12 volts. You need to see the difference in electrical pressure from one point to another, right? Voltage is pressure. If there is a voltage drop, you will not get good current flow, which prevents a component working correctly. Anything to add to that, Mr. Rich?
Okay,
Nope.
right now.
Okay, here we got about 15 loads on G402. This is a ground on a car. This is a voltage drop. This vehicle, a GM vehicle, had an issue when this person was driving a car. They said when they came to a stop or on bumpy roads, the vehicle would run real lousy and sometimes stall out. Okay? Now, it went to a shop because I got this original car from a shop. They put in, of course, a whole tune-up on this car. They put in computers. They put a fuel pump in. They had thousands in here. There's no lie. Now, I started the car up. It was cold. It was in February. I started the car up. The car started up fine. I looked around for dents, dings, whatever, so I can call the shop and tell them they had a problem, flat tire, whatever. I always walk around the car. I made the car warm up. Sounded perfect. I said, maybe this guy's on drugs. You know, he's back in '69 or something having a good time without me. Okay, there's something going on here. I get in the car. The first thing you do when you get in the car, you put your foot on the brake to put it in gear, right? I do that. This car's running like dog do. Really bad. I go, wow, this is running lousy. I got to pull up to the garage door. As I let my foot off the brake, it's running good again. Now I got to stop while I go through my door. Foot on the brake, running lousy. I go, wow, this is pretty strange. Throw up the garage door. I hear the car running good again. Pull it in. Again, got to stop, pull it in the bay, car's running bad. So the complaint coming to a stop, okay, it's real. Okay. I went to look at a wiring diagram, just like if I was going from here to Wisconsin, I'm either going to use GPS or a map. I got to look. I'm not just going to go, hell, I go somewhere west, I'll get lost. Wind up in West Virginia, God only knows what happens there, okay? Sorry about that on tape, better be careful. I look at the wiring diagram, I see G402. Now remember, G402 was for all these loads of lights. G402 is also for the fuel pump. If you recall some of these GM vehicles, it has the fuel pump relay right under when you open the hood up near the firewall, correct? And some of those relays, air conditioned, they were all interchangeable anyway. I take out my lab scope, my amp clamp, I pop it on there. I see I got 6 amps with 8 beautiful humps. So it's an 8-bar commutator. Beautiful, this thing's running. Looks good to me. Okay. I open the door up. I'm looking at my scope. I press on the brake pedal. What do you think happened when I pressed on the brake pedal? Amperage went right down. Went right down. Okay. The problem was, and here's a car we just used in a class to demonstrate the same thing, because that was a Polaroid picture that went bad. I couldn't make a good copy of it. Notice here we're using Bernie's scope, and this is like the bar or end of that graph, the zero line. Notice the lights are really not on, practically not on. We got very little current flow. We're using an amp clamp. Lights are bright. We have 2 lab scopes here actually. There's a Fluke, and here is a Bernie scope. You remember it was down here before? Look back. See how close that is to the bar? Look how high up it is. Look at all the lights are bright. We were using a variable resistor on this connection right here to actually simulate in the class the exact problem I had on a few vehicles when GM had this up here. This is the fender well. We live in an area that we have salt and stuff, right? What happened is it corroded. The stall washer and stuff was no longer making a good contact. And you know with those stall washers, you always go, I fell somewhere, screw it. Doesn't matter anymore, right? I know you all do that. Well, you take your little air gun and that little bolt there and you go, oh shit, I went too far. Oh, don't worry about it. It's in there. Everything works for now, doesn't it? Okay. Then what happens? Or like years back, it pops in my head. On a GM vehicle, a guy put epoxy on the computer ground. It worked for a while. He epoxied the bolt down on the ground. About 6 months later, his car hit and run too swift. Because the ground had deteriorated big time. It was not grounded to the bolt anymore. He epoxied the whole freaking hole with a bolt on it. He stripped it. Okay, he told me that later on. And when I took it out, what the hell is this? Epoxy was in there. So this, on the older car, was up here. We were playing with this with a variable resistor. We had set the car up, shut the trunk originally, and just put some wires out so they would check some amperage on it. You could see that if you use your brains, that is all interconnected. These lights are all interconnected with G402. They have different power feeds, even here. We got different powers going in. Now, the bumpy road, the brake pedal was out of adjustment. That's why the brain, the eyes, the nose, the ears, and hands, I looked at it, the guy must have drove the vehicle with work boots. You know when you see like a wear on the floor, but the pedal has that one little wear pattern? Because your work boots are hard and it wears it. I looked at it, go like this. I looked in the back of the door, you know, on the garage door. I saw the lights go on, off, adjusted that, not a problem. Fixed the ground. I cleaned up the stall washer a little bit. I had to drill a new hole. I moved it up into like this. It was here. I moved it over there to a good hard piece of steel or metal that was able to be a good ground. If not, I would have had to run a bigger wire. Does that make sense? So it's not rocket science, but it's something that wiring diagrams are important to look at and understand where things go. And what's it have in common? The feeds weren't in common. The fuel pump is not the same feed as the lights, correct? But the ground was the same. And how many guys missed it? I mean, the shop missed it. Not because I'm a rocket scientist. Here's one I did actually with Jim. We had checked what side with a power probe we were getting voltage on. Remember, because what do some solenoids have? Diodes. And if you don't know where the positive side is, and you randomly put the power probe, smoke show. Okay? So I tested this solenoid. It's a good idea to do it before you put it in the car. How much amperage am I pulling? And notice I'm using the meter in series here. 550 milliamps, a little more than a half an amp. Very good. Now, here's another one. This is a Ford evap solenoid, and you're going to tell me what type of solenoid this is in a minute. And I have my students that work down in the city on these cars doing this ahead of time, because even though it's Ford Motorcraft or Joe Schmo brand part, okay, we pumped it up with the vacuum pump. There's defective parts sometimes, whether they be dealer or aftermarket, correct? And it'll ruin your day, brand new out of the box. Well, we pump it up, it holds a good amount of vacuum. And let me just reduce this just a little bit here. Notice I'm checking with my power probe continuity. How do I know I got continuity? You see one leg is in on one side of it. You notice the green light's on? I'm not pressing the button. That's just telling me my coil has windings doing this from one side up to the other pin. Everyone with me? That way I know I don't have an open. I now go to the other side. Come on, wrong way. Notice I got a red light. What happened to the vacuum? It dropped. What type of solenoid is this that when there is no power applied could hold vacuum to it? Purge valve. Normally closed valve. So the computer needs to go ground on, we open it, we let vacuum through it. Make sense? Is that hard to do on components? How long do you think this takes? Seconds. Really? You know, and by the way, we're doing it crude here by holding this in there. What I like to do is you buy those Wacom or OTC little things, or you go to CarQuest or Napa, you buy all the little computer pins that fit on these perfect. You make yourself a whole bunch of them. They cost about $100 if you buy them. Okay, I got these babies too. But guess what? This saves your butt. Now, if you got nothing better to do and you want to practice soldering, okay, buy the master kit. Seriously. Start getting all the little ends and make yourself ends, because here's the problem. If you're on these little pins and you happen to slip over, sometimes you could short something out. You got an issue. Thank you, sir. Also, back probing. You see this? I love these little T-pins. You should all have them.
What do you got?
You can get these at Staples, Office Max, fabric stores. You may look a little bit funny walking in a fabric store, but that's a whole other ballgame. Some of these are very brittle. Some of them bend a lot. This is a medium-sized one. I usually use the ones that are a little longer. Here's an issue. Sometimes when you have them in here and you're testing a computer, you may have a tendency to put one here and the other one's right next to it, and they happen to touch. It didn't need a computer? Now it does. Okay? So you want to protect it. I usually use either duct tape or black tape, and I'll take a lead end, and I don't like some of the ends, like Your Snap-on motors has nice ends on it. They're plastic ends, okay? But some of you guys got those metal ends. Don't even think of using those metal alligator clips. The ends that I'm talking about, I'll just pick one up. This gentleman, he has it here. You don't mind. These are covered, okay? If they're not covered and they're metal, when you do this, they're going to pop. Especially if you're pinning a lot of stuff out. I've seen guys do this. Also, when you go in the hole, do not pierce the wire. Sometimes you do have to play a little bit of the wiggle test. Make sure you're in there. If you're still not getting a reading, take the ohm meter from one side and carefully, don't jam it in there, because when you put a round peg in a little flat thing, it's not going to work too good. You lightly touch it and see if you have resistance. If you do, you know your pin connection is good. Okay, you got something else going on there. Thank you, sir. So that is some of the stuff that we're going to be going over with you in a
I'm
second.
going to give you a situation here. All right? This vehicle came in. A vehicle came in. It has... It has a check engine light that's on. There's a PO 122 code. You can explain. All right. And the customer complains. It's a TPS. Circuit low input is the explanation of the code. All right. The customer complains of a slight hesitation. The code states that's a TPS type problem. So where are we going to test first? If you want to test the voltage, where are we going to test first? At TPS, right? All right. So I'm going to feed you a test signal to your computer. We're going to take and get the signal wire coming out of the TPS at the TPS connector. We're going to back probe the connector and give you the TPS voltage. Everybody should be on and at the same reading. What kind of a reading do we have?
0.313.
You should be reading this.
Or roughly.
Now it depends on your meter. Last night we've seen, or the past 3 nights, we've seen a big discrepancy.
Yeah. You should be close to this reading. Very close to this reading.
Close to the reading. If you're way off, if you're in the 2s or up in the 4s or something, you got an issue.
All right? All right. Now, this is the output of the TPS. Does that look, how does that look to you? And I'm going to tell you something. The spec says 0.5 volts at idle, at closed throttle. We're at idle at closed throttle.
Well, for this car, again, 500 millivolts is the spec. You're a little off, aren't you? Okay.
All right. Now, are we off the entire range? All right. We're going to take and work the TPS. We're going to step onto it and go full throttle. All right. Are we ready? Let's watch it. I'm full throttle. What are we reading?
3.598.
Should that be?
That's low.
That's low, right?
This could cause our problem, right?
Right? Could be causing a problem. All
And
right.
what should you hit on your meter at this point? Testing this. Min-max. If you have a scope or Vantage or anything that graphs out, we should be looking at something going up and down.
Right. If there's any dropouts in the signal, what's going to happen if you have it on mid-max? What should your minimum voltage be on min-max as you go through the range? What should your minimum voltage be? What you started at.
Good. What you started.
Right. What you started at.
If you see something different, or OL or OFL, depending on your meter, then you have a problem.
Or if you go to zero, if it goes down below that, you know you've dropped out. All right? So, as of right now, we have two voltage readings that seem low. One at closed throttle, one at wide open throttle. All right? Now where do you want to test? The 5 volt reference signal coming in, right? Okay? Let's test the 5 volt reference signal coming in. I'll give you a reading right now.
And I drew it basically up there, the three things we have, 5 volts, signal, and ground. Sometimes the ground or 5 volts could be in different locations, but on this one, it's right in the middle. So what do we have?
Okay.
Now, what do you think this problem is? Is this what our maximum voltage was a second ago?
Pretty close.
Pretty damn close, right? So what are you going to do? What's your next move to find out where this problem is? Where are you going to take your meter and go next?
I heard one person
Someone
say it
said
over
something
here.
right.
ECM.
ECM.
ECM. All right.
So in other words, if I'm the TPS and Dennis is the computer, I'm going to go right to that computer. Does that make sense?
You want to make sure that the computer's capable of, or is putting out that 5 volts to
Right.
go to the TPS.
Because
Okay?
something could be taking that whole circuit out. And by the way, if there's a map sensor or some other 5 volt reference nearby, and it's easier for you to test, and just put your lead there and you see the same thing is down, we got something taking this voltage down, right?
All right, I'm going to feed you a signal on a 5 volt reference signal coming out of the TPS, coming out of the ECM, going to the TPS.
So this is the computer.
That's good. 5.07.
All right,
Good?
so the computer has 5 volts coming out. The TPS has only what?
3.78.
What's wrong?
What's that called? A voltage drop, so a difference in pressure from here to there somewhere. Now, typically what happens out there in the field? What do you guys usually do in the field? You know what you do, you get a piece of wire, don't you? And you go, screw this, snip, snip, you put it in, that's a half-ass repair. Because what could we be missing, Rich? A whole bunch of problems, okay? You don't know where that line's going, okay? You're just doing a simple jump over. Your best bet is to test from me to Rich, step by step.
By step.
Find out where it's going down.
Find where the problem is. Because there may be other problems there besides. It may not be the only wire that's giving you a problem. It may be only one wire, but it's feeding multiple things.
That makes sense? Not hard to do, but again, the guy, it's his old, it's a station car. You know, don't make excuses. Fix it right. The doctor's cutting your fat ass open, you don't want him to do some half-ass job on you, right? You hopefully he does the right job. Exactly. Car could have been in a collision,
That's
something could
correct.
have melted something. Guess what? You know, wire could be cut. You never know. Test it out.
Yep.
It's not that hard to do. Do a voltage drop and you'll find out where that problem is.
Here's the situation, guys. We have a no start problem. Crank, but no start on a vehicle. All right? We do have a code. It's a PO 120. It just says TPS problem. All right? Now,
And again, TP and TPS is the same thing. So you got a crank and a no start. Look at your voltage reading.
listen. It's a TPS problem. Let's go back to the TPS. Let's test the output. What do we have? There you go. You
Now
got
he
the-
says output. What do you mean, Mr. Rich, by
All right.
output?
All right. This is the signal wire.
Signal wire.
Be more specific now.
See? Signal wire.
Signal wire.
You gotta be more specific.
Signal wire means what? What was the spec at idle? We're at idle. 500 millivolts. What are you reading? Look at the meter up there. 5 volts. What's the problem?
Why won't the car
Outside the broker.
start? Why won't the car start? Cranks but no. Ah, you got it. Clear
Now, didn't
flood.
we just have some people in a class that didn't know what clear flood was? He was just in my class. We won't mention the guys that didn't know it. But right, we had to take him out to the vehicle and said, what the hell are you talking about, clear flood? And let me tell you a story that's true. A lot of you guys have been in my feet steps, caps, fists, the electrical, all the way up to the advanced, doing an advanced class years ago. And even some of the guys that were in this class were pretty sharp. One guy was Mr. ASC Master, a certified L1 CarQuest Man of the Year. Couldn't figure this car out. The car was towed in. It towed in on a Friday night. This is a Saturday class I was doing. It was a full day. There was a new kid in the class, Paul, a young guy that reminds me of Alex over there. The kid wanted to learn. It was a 1992 Buick with a V6 in it. The shop who towed it into me, of course, this is no lie, changed multiple computers, went from CarQuest to Napa to the dealer, because everyone sucked but him, okay? He put new injectors, new coils, new wires, new fuel pump, new crank sensor, new cam, and I'm not lying. The back of the trunk was like, wow, there's a whole bunch of good parts here, okay? Now the car wouldn't start. I told you this multiple times. Your most important tool, brain, eyes, ears, nose, hands. A couple of guys, some of you guys may remember Joe Schmo, who used to come to my classes, Joe Ferrone. He used to come up all the time. He was a sharp dude. He was one of the guys in the class. Now, 15 guys in this advanced class, only 2 guys found it. The young kid who started out from my electrical class to the engine class to the computer to the fuel injection to this advanced class, he went in there when the scan tool wouldn't work. This is what scared the crap. You remember the A and B terminal, the 12-pin connector? He didn't know how this thing worked, the guy, so he couldn't figure it out. The kid took a power probe out there. It had nothing on that B terminal. He figured it out. He got a scan tool on, and guess what the scan tool showed? High voltage. He said, hey, I found the problem. I go, zip it. Okay? Come over here. Take everything apart. No one paid attention to the kid because they figured, hey, he's only a kid. What the hell does he know? So I said, you're good. Go do something else. I gave him something else to do. He was a sponge that wasn't totally wet. We get old, we have become a big wet sponge, right? We can't absorb anything. The brain is thinking about 20 other different things. You can't pull. Yeah, you just got to wring the sponge out once in a while. You go, that asshole up there talking, who gives a crap about him? I already know all this. And again, this guy that was the CarQuest Man of the Year, Mr. Cocky Ass, he couldn't figure it out. He go, oh, change that, change this, change that. Now to get to that level, not saying he's not a good technician, don't get me wrong, but sometimes we're too full of ourselves, we're too wet. We all make mistakes. I don't know everything, you don't know everything. That's why we work together, we work with each other. The other guy used his eyes and said, I see it. I go, get over here, Joe. You remember the 3.8? Where was the TPS sensor? Under the throttle. It was rusted from the water that was splashing up because the shield was gone, okay? And the little piece was stuck open. It was stuck full on for clear flood. Meanwhile, these guys are checking fuel pressure. I gave them over 2 hours. They couldn't figure the problem out. So I had 13 idiots and 2 people that knew what they were doing. Okay? Because they weren't really thinking. They were like, this is easy. We can't fix the car. It's not that easy, is it? And we all make mistakes. We've all had cars that kicked our ass, right? That's why we went over. You notice the name of this class said Part 1? Okay? Other ones down the road, when Rich and I can put some of the stuff together, it won't be as much as that baby stuff you did. But just like a baby, you need to crawl first, right? And I'm sure we gave you a whole bunch. Some stuff you knew, like I said before, and some you didn't. So you got some pieces of good information out of it already. And this little story hopefully clicks your head. Don't take for granted that you're a master technician, you know everything. Start back with the basics. Everything goes from that damn battery. And then check from there. Know how to check this simple TPS. If you got 5 volts there, it can't be a ground problem. It had to be a feed side problem.
The converse of that, of course, is now you've got an output signal on here of virtually almost 5 volts, wide open throttle. Do you have to check your 5 volt reference? No.
It's a waste of time.
Waste of time.
Just like Mike was just saying, you wouldn't have to test the ground before. Now you don't have to test the 5 volt reference because the signal's getting it. And how does it do it? It goes in and it's coming out that signal wire. Don't need to test it.
All right. But what do you have to test? The ground. All right, let's see what we've got. I'm going to feed you guys a ground signal from the TPS. What do we have there? That's the ground wire on the TPS.
Wow.
Okay, that's the ground wire. All right, so you've got that on ground on the TPS. Where are you going to go next? It's not grounded. What grounds the TPS? Remember, all three wires go to the PCM. PCM. So just like we checked the 5-volt reference at the TPS, let's check, at the ECM, let's check the ground at the ECM. Here's our ground at the TPS. Here's our ground at the ECM. You've got it. What do you got? You got ground. So again, what do we have? A differential, which is called a voltage drop.
And what are you you may not have a broken wire.
Yeah. Well, it could have corrosion. It may not completely be broken. You may have corrosion there, or whatever.
Poor connection.
But you have to find where the fault is. And again, like we said before, find the fault and repair it. Don't jump around it. All right?
And remember like the light bulb circuit before? When we had the open? You had 12 volts all the way. The light didn't light, right? On an open circuit? Very similar here, right? We have either an open or high resistance in that circuit preventing that TPS ground from coming down, right? Or the voltage from coming down. Because there's no ground. Or very little ground.
There is some.
There is some. So you got something, you may have a few strands holding there. Or you may take this off and it'll be so green and disgusting, or a connection is loose and broken. Does that make sense to everyone?
Okay, yeah.
Yes, sir.
Voltage high circuit, a lot of that on computers.
Voltage high. Now this is a key thing. Another little story we'll tell you about my buddy, Mr. Anello, where he calls me out to Newark, New Jersey with him. I haven't finished writing this story up, but this was on a brand new hybrid Camry that took a hit coming up from North Carolina on the New Jersey Turnpike. Okay? He plugs in his scan tool, and you know John has a great boot camp. You can drive around with them. You better do this first, because John drives like a madman when he's playing with his PDA and taking calls at the same time. It's crazy. Okay? So he says, you got to help me. Come out. Let's take a look at this car. Go out there. He has a guy with him in boot camp. And John opens up. He has the big Bernie scope in the back, and he's plugging his factory scan tool in. And what does he do? He gets a P31 something code, which means voltage high on high voltage circuit. Okay? Now, he's breaking out the meter. He's looking for an open somewhere. Okay? So, when you see anything where voltage is high, there's a connection open somewhere, isn't there? Okay? When it says voltage low or shorted, or voltage low, something is shorted, right? Well, the whole fix of this car was, to make a long story short, if you guys are familiar with any of the Toyota cars, like a Prius or any hybrid, they got that little orange key that goes in the back that you need high voltage gloves for, okay? The key wasn't all the way down. Now, I was right there when the body shop owner said they didn't touch anything. Now, you know the guy lied through his teeth. Someone had to touch this thing, because there ain't a way in hell this thing's going to bounce up. And besides, it took a hit in the front of the vehicle. You know where they have the electronic 201 volt air conditioning compressor? It could have been some of the wires cut and have been open, okay? But it wasn't. I went around, and within 5 minutes, I looked and I was like, I think it looks a little high, okay? You go feel it, with my gloves on. I went, I said, John, start the car up. He's out there with his big ass meter. He got the megometer. He got the scope out, you know, and it just goes down to base. And John's a sharp dude. Okay, you guys know John. He's a sharp guy. Sometimes you could overlook something. He was on overload because he had been there already, not realizing that the body shop lied to him, because I was right there when the guy spoke to him again. I said, dude, you're telling me you did nothing on this car. Nothing. They took the fender off was the only thing, because it was all messed up. And they wanted to start it up to move it place to place, or the adjuster wanted it started up. When you see that code for voltage high, just like this, okay, the problem we had, look for something that's close to open or open. In that case, it's totally open. Make sense? So very good who brought that up. Let's go clear that out. Let's do a min-max on your meter with a good TPS. So put us on the signal wire.
Got it.
Clear that thing to 0 if you don't mind.
We got it. Yep.
Okay? And let's do a sweep. So you guys that have, you're going to watch the sweep on the graph or on the scope, or a min-max should come up on your meter.
Yep. Min-max.
You guys are all okay back there?
All right. Everybody hooked. All right. There we go. All right, guys. Here we go. Our standing voltage, our idle voltage is right. Okay. Close to 5 volts. I mean 0.5 volts. Excuse me. All right. Here we go with a sweep.
Now notice my line is only going straight up and down. If you have a scope, why does my line go up and down a couple of times, Rich?
There you go.
Why is that line doing one of these like the Three Stooges, right? Why is it going straight up and down?
It's not.
Time base.
Right. It's not.
What's not?
No. I'm. Ready?
Yeah. Hey, give me another up. Go up quick. Come down. Okay.
You just want to. You want
Yeah,
to
just
check
keep-
for the timing. Yeah, you know, you want a timing differential.
Well, you see, up and down. Now we're down.
There we go. Up, down.
By the way, TPSs don't fail
down.
like they used to before, but when they did, they fail usually in that range because you always got to go from that low part of throttle going up and over. Okay. Did everyone able to get it min-max on their meter? Anyone have a problem? Need help? Again, if your meter don't have min-max, it's a piece of crap.
I'm going to give you.
To clear it out, either hold the min-max down or turn it. Do it again. Rich,
Yeah.
do that again?
Here we go.
For some reason, this one ain't catching min-max. But that would normally be the high number like he has there. Yeah.
Depends on the meter. One you may have to set, if that meter is the one that I had there, you have to set it for minimum and set it for maximum.
Oh, you gotta set it.
Yes, yeah, you have to set it. All right. I'm going to give you a glitch. I'm going to do a glitch, guys, okay? Here we go. You got it min-max set up. Here we go. It's going up.
Now, obviously, that's a big glitch, isn't it? Now, they're not normally going to be that slow, but, you know, we're
Right.
tired and old.
Absolutely.
So when we make this, we could program one in that Bernie has in the board.
Right.
That would be just a little quick dropout, okay? Like happened on a real car. So what you need to do is sometimes your meter is not quick enough, but you're going to need that meter with min-max. Most of the time it's going to grab it. Does that make sense? A graphing meter like this gentleman has a Vantage here, or some of you guys, he has a fluke scope over here. These things are going to be able to grab it. Okay? Now what we'd like to do is let's get on a fuel injector signal. Let's start it up.
Okay. We're going to give you a...
Meters go to milliseconds.
Right.
Meters find milliseconds.
And if you need a trigger on your lab scope, it's a negative. If you have a trigger set up, negative trigger.
Okay, so what we're looking at is milliseconds of time, and I want you to kind of look at this, and I'm going to blow this up a little bit. Now you really get to see something pretty neat here on the Bernie scope. First of all, the thing you're measuring on your meters, let's go with your meters first. The ms, milliseconds, you're measuring the time the injector is on from here to there. Now that's all well and good. What do you got, about 3 point something milliseconds? 3.14. Okay, pretty good, right? Now, let's go over something about trigger. You see this right here? First of all, here's my zero line. Here's 20 volts, there's 10 volts. Looking at this voltage line coming down, I can tell you what about the vehicle's car? The charging voltage. So right away, I'm not close to 12. I know the charging system's working, right? Hey, that's pretty damn good. The next thing I can look at is it's being pulled to ground, but look at this. It's here on ground and then starts coming up, doesn't it? Okay. The driver, this is a saturated driver, is pulling it down to ground. There's 3 different types of injectors out there. This is a conventional or saturated drive. The next thing you need to know is this peak is over how many volts? Well over 50 volts. It needs to be a minimum of what? Does anyone know? That peak needs to be a minimum of 35 volts. Now, if that peak ain't 35 volts, it gets about 14 plus volts going in, right? It gets pulled to ground by what? What makes it go to ground? The PCM driver, right? So the PCM does that. It releases it. It's like a buildup. Isn't this like an ignition coil? Okay? We take low voltage, we build it up because in here, we got a steel bar and windings, comes back up. So typically your fuel injector or any solenoid has 2 little doohickeys going to it. And you know what happens to the doohickey when you unplug it and the little rubber went, and your shop floor is so dirty you can't find anything. Barely find your feet down there, right? Never mind a little rubber, and you go, to hell with it, I can't see it from where I live, and you throw it back on. At least throw some dielectric grease in there, guys, because you know what's going to happen? That is going to turn into a voltage drop from corrosion over here, okay? And then you see this 35 volt peak? It may only be down to 20 something volts, 25 volts or something. It could be a bad injector, but it could be a voltage drop, right? That's key. Does everyone understand? So this is the first type of injector. Rich, there is a point to put it over there that says peak and hold. You need to put a pin in it, right next to it. Peak and hold is going to look like this. Going to have 2 peaks. The third injector that we can't show you on this board is going to be a pulse modulated injector. Okay? So 3 types, conventional or saturated, peak and hold, pulse modulated. Okay? This one is used on throttle body cars and some other circuitry, like some caravans. Some other European type cars use some of that. And what we notice about all of these, as voltage goes down, what goes up? What goes up? Okay, let's stop. Starter motor, 12.6 volts going from the battery starter. Voltage goes here. What happens to the voltage when you start cranking the car up? It goes down to somewhere about 11-ish, 10-ish, right? Okay, let's say 10. Okay, now at that point, amperage started at 0, right? What happened to amperage when voltage went down?
It went up.
It went up. What do you think is going to happen here when voltage goes down on a fuel injector? Amperage goes up and then comes down. What is the typical amperage of a fuel injector that is a regular saturated drive? Who knows?
10 amps.
How much?
9 to 10 amps.
9 to 10 amps, you'd have no computer left. But a good crack. You mean what? Who wants to help him out? It's okay to make a mistake. At least you have the balls to say something. How much? It's a little under an amp, and he's right. It's about 900 milliamps. What was the maximum that the computer can pull?
1.2.
1.2. Like we should say that should be the maximum or smoke show. Okay?
Well, I remember a while ago, one of the other classes, injectors or something like that, could pull 9 to 10 amps, but real fast.
You're close, but not yet. Peak and hold. How many amps on a peak and hold? GM, about 4 to 4.5 amps. Some of the Bosch ones, about 5 plus amps, about maybe 5 to 6 amps. But what happens? Remember the circuitry? Whoever looked at a wiring diagram on a peak and hold? The ECM had 2 little circuits coming out of there, right? One was this part right here. It had a very good ground, didn't it? Its job was to go real quick, good ground, low voltage drop. Why? So we can open that injector up quick and pull some high amperage. Very short period of time. What's the maximum amount of time it's going to leave it on? Can't be more than what before it burns it? 6 milliseconds. Good. Now, how about the hold time right here? And you see what Rich has up here? Here's, raise it up, Rich. You see, this never moves, does it? On peak and hold, and most of the time that's up higher. It could be just something on the board right now. Okay? Let it go. See, it goes in, go back. The whole part, this is the whole part. And again, this is a voltage signal we're looking at. Amperage, the whole part, how much would you expect? Less than 1 amp, about 900 milliamps. Not saying some won't pull 1 amp, but less than. This is what burnt out a lot of GM computers, by the way. Rupert, remember some of the vehicles you brought up? We caught a whole bunch of bad ones, okay? I got a whole bunch of them in my scope book. Now, how about this pulse width modulator? You know, last night we had a guy that does a lot of Porsches and stuff. You guys may have worked on some Nissan, some other performance cars that use pulse modulated. What does this thing do? It goes down the ground real quick because it's a performance car. It wants to open that injector up real fast. Remember, we use a lot of amperage even when we crank a starter over? That initial thing, we need a lot of current flow. We do that, and then what happens? It goes up, comes down, and you know what this part is? How much amperage is that part right there? About 7 amps.
Doesn't that do that on the power side, the other injector?
Some cars do power side, some do ground side. Okay, a lot of the readings when you would see them upside down, I'm a crappy artist, my brain, let's see if I can do this. How many guys have ever seen that up on their scope, upside down? Rather than an NPN, you had a PNP. Okay, meaning the computer was not supplying ground, it was toggling power. Where's my transmission guy there? That happens a lot in trannies, right? We got a lot of ground, we toggle power. No big crap, okay? So you're smart, they got tons of ground. Why run a wire that, you know, for ground when all we need to do is put power there? So good thing, Mike, saying that. So here, we do this performance-wise. Guess how much this is? You guessed it, 900 milliamps. Of course, what it did is when it first comes on, it uses a lot and then doesn't need a lot once the pinto's open, does it? Make sense? Any questions on that? So pretty simple. And by the way, you should always check amperage. If you do some diagnostics, and nowadays I wrote an article for Motor Age a while back, and it was someone on IATN that was kind of slamming something I said. And Miles Wada, who's a great tech, if you guys own Snap-on stuff, you definitely want to get on IATN snap-on for him and see miles water. This guy is a sharp dude, okay? I've met him multiple times. He's a very smart man, and he has pictures of stuff. He has captures of waveforms, especially, again, if you're using a snap-on type tool, okay? Because you can match up a lot of your stuff. And he emailed me, made me aware that someone on IATN said, hey, did you read that a-hole story in Motor Age? You know, that pintle setup was not right. In fact, Jimmy, who was here, your boss, it was the car that I worked on, multi-tip injectors may not have a big pronounced pintle, okay? Why? Because they're multi-tipped. It's not like one spray going up and you get the big humping, okay? And all I did was match up these injectors, because all 6 of them going bad. It was on a Jeep Liberty. What's the chances all 6 going bad? Come on. But if I know this is good, okay, and then it goes down to this, and that's the only 1 or 2 that are bad, all the rest are like this, I'm going to fix this, aren't I? Okay. Got a couple of new injectors. They don't want to go for the rest of them. I would suggest going for all of them. Bingo, the car was fixed. It was on his way. Okay. Amperage told me, fuel injectors just voltage like up there. I ain't going to tell me Zippo unless we're looking at system voltage, peak voltage, pulse width on time. Current is the thing that does work, right? We could have 12 volts going down to that starter. Doesn't mean a damn thing. Amperage does the work. No current flow, no work. Okay. Everyone all right with that? Let's look at an AC signal, Rich. Couple your meter to AC. Let's make believe you had a ABS problem. You know what happens many times. You look at your scan tool. Sometimes the scan tool lies here, doesn't give you the correct miles per hour. Correct? You've all come across that. It's always good to graph through the easiest thing with your scan tool, but sometimes you're going to use scope. Let's say you had your meter and you wanted to look at it, you didn't own a scope. What happens to meters? I'm on AC volts because I want to check my wheel speed sensor. I don't own a scope. I want to check my wheel speed sensor, correct? And I'm going to go and put it on AC volts. Now, if I wiggle these antennas or wires back and forth, I'm going to get a whole bunch of crazy readings, aren't I? If I got that drop light, you know, the one that burns your arm, the metal cage that you shouldn't be using, the shock blower uppers, you want to collect insurance, get one of those, okay? You don't want to do that with AC voltage. You want to find your meter and find a thing that says HZ, Hertz. Press it. It doesn't hurt too bad, by the way. Okay? Hertz is the amount of time something happens in a second. Now you take the wheel speed frequency on a level ground, by the way. Don't do wheel hops on one side and go, oh, don't match up. From one side of the vehicle to the other side. Because some of you guys don't own the scope. If you have something like Todd has a Modus over there. The Modus, 4 channels. We could go to the computer. Rich, throw me that. Here it is. We can go to the computer of the ABS because we want all 4 wheels if it has 4-wheel speed sensors, right? So his scope has channel 1, 2, 3, 4, and of course it has the ground, right? You got 1 ground. A lot of guys call me up with this question. Hey, I got a couple of speed sensors or whatever. How should I hook this damn thing up? Well, normally, you got 2 wires going to an AC generator, right? You could have 3. The 3rd wire would be a shield that sometimes you see a little box can type thing. You get it on a sucky drawer, but you know what I'm talking about, right? And also, sometimes they give you a positive. You ever notice a little positive signal? You see the positive, what lead goes on the positive? You guessed it, the red one. It's not rocket science, right? Now, if I have 1 ground in the computer, if this is right front, left front, right rear, left rear, okay? Here's the ground. We would take our ground, ground it here, red lead, blue lead, green lead, yellow lead. That's how you would do it, okay? That's how you would get all the signals. If there's only two of them, you just put two of them, you get the idea. Some of the guys that got the flukes, you could put a negative and a positive because you have the leads that come off, that tee off, okay? Also, one thing you should be aware of with your scopes, this type of scope that has one ground is not isolated between channels. Does anyone know what that is besides Pierre? Why is this important when the scope you're using doesn't have an isolated ground? Well, you see the signal we're on? That was an AC signal that Rich was just running. It was part of an AC signal, by the way. This is not good. Where's the bottom of it? Nothing going over the top, is it? Okay? Well, let's look at this reason why we need it. Let's say you want to check an actuator on the car. Give me an actuator on a car. Any actuator. Engine-wise. EGR, fuel injector, well, you got it, okay? So let's say we want this fuel injector. So we're going to scope the fuel injector right here. We're going to find out what side is B+. We're going to find out what side goes to the ground, right? We're going to take our red lead and put it here. We're going to take the black lead and ground it, correct? Now, if we only have one ground, that's our main ground. We want to do the crank sensor, correct? And let's say this car is a magnetic type of crank sensor where you would normally see the voltage go above and below zero. When the scope is not isolated, meaning they're separate inside, and these scopes that are not isolated, they do not have the capacity when you have all four of them on to keep the speed up all the time. So here's what happens. This AC voltage is going to go into your scope. Here's the picture of your scope. Goes in. This goes where, guys? To the computer. If the ground falls off, what do you think is going to happen to your computer? Does the computer like AC voltage?
No.
It will shut the computer down, and if you're unlucky, tell them the quick story, Mr. Pierre.
I was working on a race car for a friend of mine at the track.
Loud, Mr. Pierre.
Okay, I was working on a race car for a friend at the track. It was in the pits between qualifying and the race, and I had a scope, a fluke that does not have an isolated ground on it, and of course it was a very loud car. I had the extra ground wire on it to protect it, but at some point I heard a little clicking noise and the car died. My ground wire fell off. Now I don't remember exactly what I was on, but something high voltage and something low voltage, no doubt, and it smoked the ignition module.
Now sometimes you're not that lucky.
15 minutes before the race.
Right here in this bay, when this first happened to me, I had a Fluke 97, a Tech 222, and a Fluke 98. I was doing a class. I had the older Jeeps had the AC crank sensor, right? Because you don't know what you don't know until it happens to you. So here I put the Fluke 97 and the Tech 222. The Tech, that's a Tektronix scope, had isolated grounds. The Fluke only isolated the grounds at the time, like the Modus does now, by the one ground wire. The Fluke 97 did that. The Fluke 98 had two leads that came off. As soon as I hooked the Fluke 98 up, going to the crank sensor, going to the fuel injector, it shut that Jeep down quicker than you could turn the key off. And it would not start the vehicle. So what do? Now I got guys, it's 10 o'clock at night, they want to go home, and this is some dude in the class's new Jeep, by the way. So he's not a happy camper. Screwing his Jeep, where's my car? Okay? So I said, hold it, this is crazy. It never happened to me before. Because again, you got to experience stuff in life. So I said, what the hell did I do? All I did was put this Fluke 98 on it. I took the Fluke 98 off, boom, starts right back up. Put it on, boom, shuts it right down. Then I said, hold it. I took the leads from the Fluke 97, because the 98 and the 97 was similar. I put it in the top, the little ground COM port. You got a 98 over there somewhere. One of you guys have it, you, right? Hold the 98 up. The bottom part, face it like this. The top part, there is a common lead that isolates the two channels. I took the 97 leads, plugged it in there, took the red lead off, put the black lead, put them on there. The Fluke 98 worked fine with the Fluke 97 leads. Took the 98 leads that were a B and C with the split off, put it on there, shut the vehicle right down. I called George Menchu up. He was known as the lab scope guru, sharp man. Didn't know. Called Corey Glassman up from Fluke. He was their top automotive guy. Didn't know. Finally, I got this guy at Fluke who says, hey, his name's Hilton. He does like the 190 series scopes. He's the project engineer. He says, look, I don't know a lot about cars, but I'll tell you about isolated grounds. To me, it sounds like you're putting an AC voltage into something and it's going to the computer and burning it out or shutting it down, whatever's happening. Because the scope is not isolated. Now, all those new 192s, 196s, or any of the 190 series scopes or Tektronix scopes, they're all isolated grounds. A lot of the scopes you're using, whether they be Snap-on, OTC, or whatever, as far as I know, I haven't seen one of them with an isolated ground. So you need to be careful when you put that alligator clip on something. You better make sure the alligator clip stays on there and doesn't pop off. Or you don't have, like I've seen some guys, they got grease and junk in between the lead. It's not really in there. They don't get a good reading. You could run into some problems. That makes sense to everyone. Okay? So there goes a little story. Let's move on to AC, both sides now. Well, you only did one side, right?
Yeah, we only had one side.
Okay, so go to the opposite side of one side. Opposite side of one side.
Opposite side.
So now you had the peak going up first, right? Let's look what it looks like going on the opposite side. Remember I just went over, you should have the pin. The B plus should go to B plus on the ground.
There you go.
Okay, now you should all have something like this. Notice we're above and below zero. Now, how about if we had a glitch? We talk about signature. Let me show you signature. I'm just going to spread this out a little bit. One to two good readings like this is a signature, meaning I could look at the amplitude height up top or on the bottom. Once I know that's good, if this car is cutting out down the road, and the meter is probably not going to help you here, okay? This car is cutting out due to a bad crank sensor. I need to take my time base and do what with it? I need to do this. I need to tighten it up. Now it looks like a bunch of mishmash, right? Everyone see that? Okay. Do you see that little part that just happened? Do it again. You see that part that just dropped out? Now the Bernie scope, or ATS, I keep calling it the Bernie scope, he's taking care of this, but you don't need a Bernie scope to do this. We could do it on a Pico, we could do it on a Modus, we could do it on a Fluke, we could do it on anything. Just take your time base and make it tight. You don't care about signature at this point. You don't give a damn how it looks. You already looked at that. You got a drivability issue here. Now when Bernie did that, he did something like this with a deep record. Give me a quick glitch. Okay, now you know the Bernie, you can blow stuff up to holy heaven. You can obviously see we got a problem. But you don't need this scope to do it. It just does it easy. And by the way, this was one click of a button on the Bernie scope. I have both scopes. I like the Bernie scope better. But Pico's a good scope. So with this, all we need to do is hit a button, and you could put on as many signals as you want. Any little problem, you could zoom, go back. That. So we can see it's right here. You could blow it up indefinitely. You could catch it right away. But we didn't need to do that, right? Couldn't we have done this here? Sure. We could do the same thing. There it is. We could hold and freeze it or go back. Also what Bernie does is right here, this is a little counter that you notice I can go, look at the yellow. You see the break in the top? He's always graphing it as well. So I could walk away and go back and replay it at any time. The Fluke 190 series scope. You don't have to hit any record. You could go back and play back that problem. I use that scope all the time. Nice and easy. I could walk away, something happens, I don't have to worry about it. A lot of other scopes, got to be careful triggering on it or whatever. So we could find a glitch if we do what to the time? Tighten it up. Now, if you had a car cutting out down the road, maybe you're on a Volvo or some other vehicles where you're driving down the road and the car seems to cut off. How many times ignition switches heat up and there's a problem? Do we need a scope for that? Not really. We can use a meter on min-max. If we got a power and a ground type setup and you're not sure what's cutting out, if the voltage is supposed to be 14.7, 15.1, whatever the voltage is coming out of the system, right? You're going down the road, we'll say 14 to make life easy. Going down the road, the car sputters. If you noticed your meter that was checking the voltage going into the computer went down on your min-max, it hit 7 volts, you got a problem with the feed side, some loose connection or something. We also need to check what side? The most important forgotten side, the ground side, right? How about if the feed side never fell? We don't need to use a scope on this, do we? Min-max again, and guess what? The ground is 100 millivolts or 50 millivolts, 50 millivolts. All of a sudden the car heat cups, when you went to hit min-max, it went up to 2.3 volts. What happened? We lost the ground. Does that make sense? Okay. So meters come in handy. You need milliseconds, you need min-max, and you need frequency. Frequency, again, the amount of time of something happens in a second. And if you're doing a voltage drop, you don't want to confuse yourself and pull out a Modus, a Genesis, scope thing. Your mind's going to go wacky. You're going to hit the wrong frickin' button. You take a meter, you put the damn thing on millivolts. You know you shouldn't have more than 200 millivolts voltage drop on a non-computer circuit. You know you shouldn't have more than 100 millivolts voltage drop on a computer circuit. It ain't a lot of shit to remember. It's not hard to turn a dial or hit a button. But when you get into more complicated scopes and stuff, you hit one button and you can get lost. The other night in New Jersey, we had a lot of guys that bought the new Verus. Beautiful tool. Phenomenal, okay? Not one guy knew how to use it. Not one guy there knew how to use it. And some of them had it for months. Like, what do I do? And it's too complicated. They didn't bring their meter. They brought that, and they were having issues trying to use the meter part of it. Now, I'm sure with some practice it'd be easy, but the bottom line is the more crap you have to remember, the tougher it gets. When you're looking at electrical problems, use a meter for that. Don't take out the big guns when you don't need the big gun, right? You don't take the bazooka out to kill the bird. There'll be no bird left, okay? And you shouldn't kill birds because someone will complain. How many of you guys have issues sometimes looking at ignition stuff? You think you got to buy all that happy, fancy type stuff for coil on plug and or all these different connectors. Go to primary ignition. That's what we're going to feed you right now. Go to primary ignition and you won't have a problem. Start it up, Rick. Okay, so if you're looking at primary ignition, let me change my time base.
Yeah, that's DC.
Yep, DC. By the way, you see trigger? You see how this is walking across the screen? You notice how that's walking across the screen? When trigger is not set correctly, you may not get a reading or it'll walk across the screen. When I move trigger, I could see the whole ignition setup right there.
Move it down a little bit, Jerry, you'll get a stable. There you go.
Okay, so we can see the spark line right in here. Raise it up a little bit, Rich. Let me get position. Let it go. Okay, so right here, let me do a little more position. Position. Yeah, hold on. Okay. We have the coil oscillations right here. The square going down is the dwell, then we got the firing line. Raise it up a little bit, Rich. We could compare this for each cylinder, couldn't we? And better yet, and again, this is primary, that means you go into the negative side of a coil. You can match the lines up top, the firing line, to see if you got a problem. You could take your scan tool, and if you have mode 6 information on misfire, you could start looking at this. You could also take an amp clamp, and rather than back probing, we could simply clip this on, and we could see the amperage there. Does that make sense? So there's easy ways to diagnose stuff. Hopefully this information helped you. Well, look for part 2 in the future. We want to thank you guys for coming out.
Yeah, thanks a
If you
lot.
have any questions, feel free. Don't forget your evaluation sheets. And thank you again.